Hello. Good morning, all of you. Am I
Good morning.
okay? Very good morning, all of you. Uh, is my screen visible to all of you?
Yes, sir.
Okay. Um, After this long period, this is our first class. Actually, so we stopped somewhere in the multi-stage amplifier. I think bandwidth calculations are over and analysis of cascade or cascode are pending. Okay, so let us start with a new topic. Okay, after let us go with the power amplifiers now. Then we'll feedback and oscillators. Then I will go back to multi-stage amplifiers. Okay, so let us start with a fresh topic here. Uh, First, this is the second part of module 4. Module 4 power amplifiers. Okay, so module 4, the first part is the multi-stage amplifiers and the second part is the power amplifiers. So in this power amplifiers, basically what we can tell is, this one is, suppose if you take the public addressing system, what we call public addressing system. Public addressing system. So the block diagram says this is input, so means nothing but mic, what we are speaking, this is the mic, and this is stages, like so what we'll give, we will give to the multi-stage amplifier, this is the first stage and this is the second stage and this is, and so on, and this is completely to the stages is nothing but it depends on the requirement. It depends on the requirement, like for example whether you are delivering a lecture or you are giving a speech at that what we call the huge crowd, like politicians generally will give for the when at the time of elections. Okay, so that depends on the situations. We'll use that first stage, second stage, third stage. But because if you take the first stage, I'm giving input as a 20 millivolts as input, for example. So first is, let us assume that it is amplified 50 times. 50 times of 20 milli, you will get so 1000 millivolts. So approximately 1 volt I can tell. Okay, so I can tell 1 volt. So 1 volt. So suppose if you are not satisfied with 1 volt, so why? Because this 1 volt is sufficient when you are giving a lecture in a class. Why? Because in a class there are 60 or 70 members. Okay, so this 1 volt is sufficient. But you are giving a seminar for this in a conference. Okay, so where the people, people are there in terms of thousands, like 10,000, 20,000. This 1 volt is not sufficient. So for that situation, so you must go with the multi-stage amplifiers. Okay, so multi-stage amplifiers. So this 1 volt is not sufficient. For that, we should go for the multi-stage. This 1 volt is given to the input of the second stage, so that again it will be amplified. It will use again 5 volts or 10 volts, like that. 5 volts or 10 volts. So that depends on your requirement. You can take it. Depends on your requirement. You can take also a single stage, 2 stages, and 3 stages. Okay. So till to this point, okay. So this till to this point already we discussed. This is clear. Okay. So in general, so this first stage, second stage, and third stage, whatever the stages are, we generally use C amplifier. We'll use the C amplifier. Okay. So in the C amplifier, why? Because it gives the high current gain, high voltage gain, moderate input impedance, moderate output impedance. So these are the characteristics of a CE amplifier. So we will use this C amplifier for the place of amplifiers. But coming to this output impedance of common emitter, output impedance of is so moderate. Moderate is nothing but so you can assume that in terms of some kilo ohms, in terms of kilo ohms. So in terms of kilo ohms, we have to match the output should be what is the output? So this is the loudspeaker. Okay, this is the loudspeaker. So if you give the output of the multi-stage amplifier directly to the loudspeaker, so this is the loudspeaker. If you give, okay, if you give the output of the second multi-stage amplifier directly to the input of the loudspeaker, if you give this directly here, what happens is the loudspeaker input impedance is in terms of ohms, like let us say 5 ohms to 20 ohms. This is the range of input impedance of the loudspeaker. Okay, but output of this multi-stage amplifier is it is in terms of kilo ohms. So there will be some mismatch between the impedances. So this is in terms of kilo ohms and this is in terms of ohms, that is 5 to 20 ohms. Okay, there is a mismatch. So whenever the mismatch occurs, what happens is there will be some kind of the noise will come out. Okay, there will be some kind of noise. So we should see that the output impedance of the multi-stage amplifier must match with the input impedance of the loudspeaker. Okay, the output impedance of the multi-stage amplifier should match with the input impedance of the loudspeaker. Okay, to match these two things in between the loudspeaker and multi-stage amplifier, we are inserting one more block is power amplifier. Power amplifier. Okay, is power amplifier. So what is the need of power amplifier here? So in a public addressing system, so input is mic, so that we what generally what we are speaking, and output is the loudspeaker. In between we are using the multi-stage amplifier, so which amplifies our voice in terms of like a volt, 1 volt or 2 volt, 3 volt, like that. Okay, if you that depends on the requirement, you can go with the number of stages, 2, 3, 4, like that. Okay, and if you give the output impedance of the multi-stage amplifier directly to the loudspeaker, what happens is there will be some mismatch, output impedance mismatch. Okay, so impedance problem will be occur. So because output impedance of the C amplifier is in terms of kilo ohms and the input impedance of the loudspeaker is ohms. Okay, so to avoid that impedance, to avoid that, so we are inserting one power amplifiers. We are inserting one power amplifiers in between the loudspeaker and multi-stage amplifiers. Okay, so to match the input impedance of this multi-stage amplifier, to match the impedance between the output stage output impedance of the multi-stage to input impedance of the loudspeaker, we are inserting the power amplifier. This is the first objective of. Okay, so objective is why we are going for what is the need of power amplifier is first one is for impedance matching. For impedance matching. For impedance matching. Okay, so this is the first objective of power amplifier. The second point is okay, the here for general, if you take the some last stage of the multi-stage amplifier, so that is also C amplifier. See, this is the C amplifier structure, and this is bypass capacitor. Okay, this is input. So this is the C amplifier structure. So RC, R1, R2, RE, CE, CC1, CC2, and this is RS and input. Okay, this is the C amplifier. Now this is output voltage. So from this you can write output voltage is equal to VCC minus ICRC, can write. So V naught, here the voltage drop across this V naught or VC or VCE, whatever you can take it, is equal to, this is VCC minus what is the current flowing to this IC, so ICRC. So V naught is equal to VCC minus ICRC. So means because of this load resistance occurred here, because of the load resistance of so placed in the C amplifier, so there it causes some voltage drop across the in the collector terminal. So V naught is equal to VCC minus ICRC means so it causes some drop. Let us assume that it could be 1 volt or 2 volts like that. But this is what this is 12 volts. And so one or minus two you get approximately equal to 10 or 11. Okay. Actually, you have to get this V naught is equal to VCC. This much of voltage you have. This much of voltage you have to get it. Okay, but so because of the voltage drop across the RC resistors, you are losing some information. So that your output voltage is getting decreased. So it's actually you are getting this 10 volts. Okay, so to avoid this, to retain our the remaining 1 volt or 2 volts voltage, again we are going for the power amplifiers. So to improve output voltage, to improve output voltage. Clear? So this is what. So this is the second object. The first object is for impedance matching. Second object is to improve the output voltage. So these are the objectives of power amplifiers. The two important. Why we are going for the power amplifiers? So still we have so many amplifiers like multi-stage, single stage, or power feedback amplifiers. All those things. Why we are required only power amplifiers? So the first point is for impedance matching. Second point is to improve the output voltage. Okay. So these are the two main objectives. Okay. So two main objectives. So now objectives here. Now coming to this. This is the objective. Next, coming to this power amplifier versus voltage amplifier. Power amplifier versus voltage amplifier. So, power amplifier versus voltage amplifier. What is the difference between power amplifier and voltage amplifier? Voltage amplifier is general our CE amplifier, okay, or CB amplifier. Voltage amplifier means. So, power amplifiers means what we are using these power amplifiers to to match the impedance and to improve the output voltage. So, this is a special amplifier. So, now we are discussing here. So the first point is the power amplifier. So you see, remember important point. Uh, Is my screen visible? Hello?
Yes, sir.
My screen is
Sir.
visible? Hello?
Yes, sir. It is visible, sir.
Yeah,
Sir.
it's visible, sir.
Okay. What it is displaying?
Screen broad.
Screen.
Now it's visible, sir.
Okay.
Yes, sir.
Okay. So the main difference between power amplifier and voltage amplifier is, so you see, if you take the current amplifier is nothing but the amplifier which amplifies the current. Okay. The amplifier which amplifies the current is called the current amplifier. Voltage amplifier is nothing but that amplifier which amplifies the voltage is called the voltage amplifier. Okay. The amplifier which amplifies the voltage is called the voltage amplifier. But power amplifier is not like which amplifier amplifies the power. Okay. This power amplifier will not amplify anything. The power amplifier will not amplify anything. So power amplifier is nothing but which converts the AC signal to the DC signal to AC signal. The power amplifier which converts the DC signal to AC signal, as well as and the power amplifier which is used to improve the efficiency, So efficiency is in terms of like, so you are giving some input signal and you are getting output through the multi-stage amplifier. You are losing this information, this 1 volt and 2 volts you are losing it here. Okay, so this power amplifier is used to improve the efficiency, means we are going to retain this 1 volt and 2 volts also. So it doesn't mean that the power amplifier means it amplifies the power. Okay, so power amplifier is used to amplify, is used to improve the efficiency, and so it improves what we call improves the efficiency and to retain the output voltages, so some drops. Okay, and now, so this is the basic information, basic definition. So here I'm writing, so it provides high power. Okay, so high power to the high power to the load, and hence large voltage and current signals handling is handles. Okay, so power amplifier is nothing but it provides a high power to the load, so hence it large voltage and large currents can it handle. So the power amplifier is nothing but it's a large signal power amplifier, large signal amplifier. Another name for the power amplifier is large signal amplifier, right? So the first point is it provides the power to the load and hence large voltage and current signals can handle. Whereas voltage amplifier, here voltage gain is important. Voltage gain is important here. Okay, here what is important to handle the large voltages, handling the large voltages and large currents are important here. So in the power amplifier, whereas the voltage amplifier, voltage gain is important. Okay, so see the difference. So for power amplifier, the important point is to handle the large voltages and currents, and whereas a voltage amplifier what we call voltage gain is important. And second point is H parameter is not applicable here. Is not applicable. Here it is applicable. Why? Because we'll do the H parameter analysis for the C amplifier. So this H parameter is applicable here. For the power amplifier, we will not use any kind of the H parameters. Okay. So Here transformers are used. Transformers are used for coupling, and here resistance and capacitance are used for coupling. Okay, so next for fourth one, amplifies both AF and RF signals. Here is also same, amplifies both AF and RF. This is same point for both. Okay, so these are the differences between the voltage amplifier and power amplifier. Okay, so first thing is power amplifier. Please remember one thing. It's also called as large signal amplifiers. The main motto of the power amplifier is to match the impedance and to improve the efficiency. So the definition of the power amplifier doesn't mean like so it amplifies the power. So power amplifiers will not amplify any signal. The only thing is it is used to improve the efficiency. It is used to improve the efficiency, whereas voltage amplifier amplifies the voltage, current amplifier amplifies the current. Okay, the second point is H parameter is not applicable for the power amplifiers. Why? Because H parameter is applicable for only small signal amplifiers like CE, CB, CC, small signal amplifier, whereas the power amplifiers are the large signal amplifiers. H parameters is not applicable. Next, the power amplifiers, the transformers are used for the coupling, whereas the voltage amplifiers, resistor capacitors are used. And coming to the power amplifiers, it amplifies both A and AF and RF. The voltage amplifier also amplifies both AF and RF signals. Okay, so this is what that voltage versus power amplifier versus this one. Okay, so next coming to the classification of so this is just everything about the introduction. Okay, so everything about the introduction here. So now let us come into the classification. Classification of power amplifiers. Okay, so first point is class A power amplifier. Class A power amplifier. Class B power amplifier. Okay, Class C power amplifier. Class AB power amplifier. Okay, so these are the four types of power amplifiers, right? So class A, class B, class C, class AB. Okay, four types. So this is based on operating point. Based on operating point, say based on operating point is position of operating point. Based on position of operating point, right? Okay, so position of operating point. So usually we know that. So where it will be the operating point? Can anyone tell? So what is the
Midpoint.
region.
sorry?
Midpoint.
Midpoint of the active
Midpoint.
region. So that it gives the better results. Am I right? So if you choose that midpoint of the active region, so the stability factor will be stabilized, so that amplifier construction will act as an amplifier. Now, if that operating point varies, suppose if it is near to the saturation, if it is near to the cutoff, and it is near to the midpoint, and if it is below the x-axis, what happens? That based on the position of the operating point, so power amplifiers are classified like this. Class A power amplifier, Class B power amplifier, Class C power amplifier, Class AB power amplifier. But in our syllabus, we have only two, so that is Class A and Class B. Okay, so in our syllabus, we have only two, that is Class A and Class B. So here there are the two types, that is series fed, and the second is the transformer coupled. Transformer coupled. Okay, so in the Class B also two types. One is push pull. Okay, push pull Class B power amplifier. Another is a complementary. Okay, so here the main important thing is, if you know the series fed, it is easy to get it transform coupled. If you know the push pull, it is easy to get the complementary. So only thing is, in this complete power amplifiers part, that is the second part of your module 4. Second part of module 4 is the power amplifier. In the power amplifier, the very important questions are, so these things only. So that is a important question topics. So that is a series fed Class A power amplifier, transformer coupled Class A. Second one is a push pull Class B, and complementary symmetry Class B. So 4. Okay, but only thing is, if you know that this one, this is easy. If you know this one, the second one is easy. So only these two are very important. If you know that these two, the remaining two easily can get it. The only such small point is different, so that I will tell you. Okay, so out of the Class A and Class B, so in the SWE, so one question will be there in SW, either Class A or Class B, either Class A or Class B. So one question will be there. It is for 16 marks. It is for 16 marks. So this question will be there in the what we call final examination, SW, either Class A or Class B. You prepare these two, definitely one question will be there. So this is for 16 marks. This is for 16 marks plus 2 marks questions is there. 2 marks questions like in part is there, no? So the 2 marks questions, maybe they may ask what are the classification of power amplifiers, or what is the definition of power amplifier, what are the differences between power amplifier and the class voltage amplifiers, what are the objectives of the power amplifiers. These may they ask for the 2 marks question. Okay, so this is the classification. So only two. So please, if you learn these two, okay, definitely, so you can get 16 out of 16 in this. Okay, including problems are there, so that I will tell you. So 16 out of 16 you can get it. Okay, 2 marks, one 2 marks question will be there. So that is also based on this classification or some definitions or difference. So all those things. Okay, so before going for these different this one, so I will tell you what is Class A and what is Class B. Okay, so Class A power amplifier, Class A power amplifier is, no down, the power amplifier is said to be, the power amplifier is said to be Class A power amplifier, Class A power amplifier, if the Q point is nothing but operating point or Q set point. Q point and input signals are selected such that the output signal is obtained for a full cycle for a cycle, full cycle. For this, position of Q point is approximately at the midpoint of load line. Okay, this is the definition of class A power amplifier. Is what? Class A power amplifier is said to be class B. Power amplifier is said to be class A power amplifier if the Q point and input signal, the Q point, okay, Q point and input signals are selected such a way that output is obtained for a full cycle. Please note it point. Q point and input signals are selected such a way that output signal is obtained for a full cycle. So means if you are giving input signal, the output should be complete cycle. Output should be the complete cycle. So for this, if you get the full cycle, then it is called the class A power amplifier. To get the full cycle, the operating point should be in the midpoint of the load line. That is general what we learn in the C amplifier. So general C amplifier is also we can call it as a class A power amplifier with respect to the operating point. Okay. So this I can tell you that I can draw the waveforms, output waveforms. This is output waveform. Okay, so the load line is this. This is input signal I'm giving. This is my this is IC and VC voltage. Okay, see, this is what the load line analysis, the load line. So now see, I will draw the output waveforms. Output waveforms. I'm giving input cycle like this. Input cycle like this. Okay, so this is my input, and this is IC waveform, and this is VC waveform. IC is this one, IC, and this is IB, and output waveform is this, out of phase. Anyway, it is C amplifier now, so out of phase. This is VC. So I'm giving some complete input signal here. Okay, I'm giving input signal, and output also I'm getting complete output waveform. Okay, I'm giving output also complete signal. So input is full cycle, I'm getting output also full cycle. Okay, so to get the output is a full cycle, I'm choosing this operating point at the midline midpoint of the active range. So this is what Q point IC comma with the VCE comma IC. Okay, so this way, if you take the load line, so if the operating point is the midpoint of the load line, so if you give the input as a 360 degrees conduction, see here one more important point is the conduction angle. The conduction angle. Conduction angle is nothing but, so what is the conduction angle of this? So 360 degrees is the conduction angle for this. So means it is conduct for 360 degrees. So the 360 means it is in terms of y-axis. In terms of y-axis, so that positive peak is there and the negative peak is there is nothing but this is 360 degrees conduction angle. So for class A power amplifier, output will be 360 degrees conduction angle. So output ikkada 360 degrees is our input to, so output is also you're getting 360 degrees conduction angle. This is the positive peak as well as the negative, so the negative peak and positive peak. So the conduction, what is the conduction angle for the class A power amplifier is the 360 degrees or 0 degrees. Okay, so this is the class A power amplifier. This is class A power amplifier. So for input 360 degrees conduction angle, output is also we are getting 360 degree conduction angle. So to get it, we are fixing the operating point at the midpoint of the load line. Clear? So this is class A power amplifier. Next, class B power amplifier. Class B power amplifier. Okay. So same definition. The power amplifier is said to be class B power amplifier. Okay. So the power amplifier is said to be class B power amplifier if the Q point and input signals are selected such that output signal is obtained for a half cycle. Output signal obtained for half cycle. Half cycle. Okay. Whereas class A power amplifier is full cycle and this is half cycle. Class B power amplifier is half cycle. Okay. So this for this Q point lies on x-axis. Q point lies on x-axis. Okay, so the load line is this. Load line is this. Okay, so this is Q point. This is Q point on lies on x-axis. So for this, I'm giving input signal like this. For 360 degrees, I'm giving input signal, but output I'm getting only 180 degrees conduction angle. So whereas the negative peak, it is below the cutoff region. So below the x-axis means that portion will be clipped off. That portion. So why? Because the positive peak is above the positive peak is nothing but above this point. Okay, above this Q point. So your positive peak is processed, and the negative peak, you see the negative peak where it is the negative peak, and this is the below the Q point. So the negative peak will not process here. Negative peak will not process here. That will be clipped off. And the similarly, this is what is the current? This is IC current, and the voltage will be like this again. Only one peak, and the negative peak will not process. That is indicated with the dotted line. So only positive peak will be processed here. Okay, so the waveforms will be like this. This is my input signal. This is my input signal. Okay, so IB and output is positive peak means only it passes, and the negative peak will clip, and again it will process the positive peak. Okay, and the output voltage, what we call so this one. Okay, so this is what VC, output voltage, and with the phase angle is there, phase shift 0, phase. Okay, so output voltage is we are not getting the positive peak, and here we are not getting the negative peak. So because of the phase angle. So what is the conduction angle here? 180 degrees only. Conduction angle. Here what is the conduction angle? 180 degrees only. Here what is the conduction angle? 360 degrees. I'm giving 360 degrees conduction angle as input, but I'm getting only 180 degrees conduction angle because the x-axis, the Q point is lies on x-axis. Lies on x-axis. Okay, so the power amplifier is said to be class B power amplifier if the Q point and input signal are selected such that the output signal is obtained for a half cycle. Whereas class A power amplifier is a full cycle, but class B power amplifier is the half cycle. Okay, so this is what class B power amplifier. So the conduction angle is 180 degrees. Whereas the class A power amplifier conduction angle is 360 degrees. Okay. Next, class AB power amplifier. Class, let us say see about class C. Class C power amplifier. Class C power amplifier. Okay, so the definition is again, the power amplifier is said to be class C power amplifier if the Q point and input signals are selected such that output signal is obtained for a less than half cycle. Okay, output for this is output signal is obtained less than half cycle. Okay, less than half cycle. So if output signal is getting less than half cycle, then we'll call it as the class C power amplifier. So now tell me, to get the less than half cycle, where we have to take the operating point? Where is the operating point? Can anybody tell? So to get the less than half cycle, output, the operating point is fixed at. Am I audible, all of you?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now, output signal is obtained for less than half cycle means where we have to take the operating point. If you take the midpoint, we are getting 360 degrees conduction angle. If you take on x-axis, we are getting 180 degrees conduction angle. And if for this is less than half cycle, the conduction angle not even 180. Not even 180. And less than 180 degrees conduction angle రావాలి. And operating point ఎక్కడ తీసుకోవాలి?
Between midpoint and x-axis.
Between, see, midpoint లో తీసుకుంటే 360 అమ్మా, x-axis తీసుకుంటే 180. 180 కన్నా ఇంకా తక్కువ రావాలంటే ఎక్కడ తీసుకోవాలి?
Below x-axis.
Below the x-axis తీసుకోవాలి. Below the x-axis తీసుకోవాలి. So the operating point is this. This is Q point below the x-axis. So here I'm giving I'm applying the signal like this. I'm apply the signal like this. So now what happens? So what will get output waveform వస్తుంది. So till to this point, till to this point, is what is this portion? Below the x-axis. This portion below the x-axis. So means this yellow portion, yellow colored portion is there, no, that will be clipped off. That will be clipped off. So what will get? See, this portion only will processed. This portion only processed, and this is everything will be clipped off. Similarly, output also. This portion only will be processed. Okay, so the waveforms are this is input signal 360 degrees conduction angle IB, and output is equal to what? only this portion will be processed. This portion only processed. Okay, so this is IC, and output is equal to what? And if phase angle is there, no? This portion only processed. So now what is the conduction angle? Is less than 180 means you can take you can tell that 90 degrees, and this is 90 degrees. Conduction angle is 90 degrees, 90 degrees. This is class C power amplifier. This is class C power amplifier. Okay, so the power amplifier is said to be class A power amplifier if the Q point and the input signals are selected such that the output signal is obtained for less than half cycle per a full cycle input. So for this, Q point is the below the x-axis. Okay, this is class C. And the next class AB. Class AB. Okay. The last one, class AB power amplifier. So the class AB power amplifier, the power amplifier is said to be class AB power amplifier if the Q point and input signal are selected such that the output signal is obtained more than 180 degrees but less than 360 degrees. Okay, so output signal is obtained more than 180 degrees but less than 360 degrees, right? This is the case. Now tell me, where is the operating point?
Between Q point and x-axis.
Q point means what?
Midpoint and
Midpoint.
x-axis.
Midpoint and
X-axis.
yes, exactly. So midpoint and x-axis. So lies between. You will get it. So this is the midpoint actually. So I'm taking the operating point here. This is Q point. Okay. So my input signal is, I'm applying to the x-axis here. Okay. So sorry. So I'm applying the input signal like this. Okay. So here we'll get, so Q point x-axis, this is the x-axis signal. So above the x-axis means this portion will be processed. This portion, yellow colored portion is there, no, that will be processed. Why? Because that portion is above the x-axis, and the below the x-axis is nothing but that is a cutoff region. So that below the x-axis portion will be clipped off. So I'm drawing with green color now. So this will be clipped off. This portion will be clipped off, and yellow colored portion will be processed. So this one you will get it sine this portion will be processed. Similarly, okay, this portion will be processed. Okay, so this is IC and VC. Okay, so waveforms are, this is input IB, this is IC, so this will be clipped off, and the negative portion is this one. So the conduction angle is 270 degrees, 270 degrees, this is 360 degrees. Okay, so this one, this is class AB power amplifier. Okay, so these are the classification of power amplifiers. Next, we will see the differences, comparison. So class A, B, C, AB. First, operating cycle or conduction angle. What is the operating cycle for class A?
360.
360. Class B?
180.
Class C?
Less than
Less than 180.
Less than 180. Next AB?
in between
More than
180.
180, less than.
So 180 to 360. Next, position of operating point. Position of Q point. Class A?
Midpoint.
Midpoint.
Okay, midpoint. Here?
On
X-axis.
Okay. On x-axis. Next.
Below
Below
X-axis.
Below
Okay.
x-axis.
Below x-axis.
Between midpoint and X-axis.
Between
Midpoint and X-axis.
midpoint and x-axis. Right. Next, efficiency. Efficiency. Class A power amplifier with respect to efficiency is 4, so that is 25 to 50%. 25 to 50%. Class B is good, 78.5%. Class C is highest, excellent, 100%. Class AB, it lies between 50 to 75%. Okay. With respect to the efficiency, Class C is good. Class C is good. It has the highest efficiency. Okay. Next, distortion. Okay. No distortion. Here it is moderate. Here it is highest, and here it is moderate. Okay. So why can anyone tell me that for class C power amplifier efficiency is 100%, but distortion is also highest? Okay, so why this class C power amplifier has highest distortion, though it has 100% efficiency? Can anyone tell? The reason is class C power amplifier conducts for less than 180 degrees. Efficiency is nothing but, so whatever the input signal that you are getting, how much it is converted. That depends on only that available portion. That depends on only that availability portion that is converted or not, that is efficiency. The distortion is actually you are giving 360 degrees conduction angle, but you are getting only less than 180 degrees. In my means 90 degrees, for example, 90 degrees conduction angle you are getting. Compared to class A, class B, class AB, this is the least conduction angle. Okay, so that is the reason for the class A 360 has no distortion. 360 to 360 వచ్చేస్తుంది. So class B and class AB, okay, 360 కి 180 వస్తుంది, ఇక్కడ 360 కి 180 to 360. So these two are the moderate. Okay, but class C కి వచ్చేసి less than 180 అంటే highest compared to remaining all. So this is highest distortion. Okay, so these are the classification of power amplifiers. I mean, sorry, comparison of power amplifiers. Okay, clear?
Yes, sir.
So, okay, now take the heading. Next, class A power amplifier. So in the class A, there are the two I told. Okay, what is that? What are the two types? What are the two types of class A power amplifiers?
Series fed, transformer
Series fed
coupled.
and
Transformer coupled.
yes, series fed and transformer coupled. First, let us see series fed. Okay. Series fed class A power amplifier. Series fed class A power amplifier. Clear? Now coming to the circuit of this. So another name is series fed are directly coupled. What we so slash we can tell that directly coupled. Series fed or directly coupled class A power amplifier. The circuit is this. Okay, this is a class A power amplifier and output waveforms are Okay, so this is a class series fed class A power amplifier, the circuit diagram and the output waveforms. Now see, coming to the circuit diagram, and it's a simple CE amplifier. It is in the it's like a fixed bias. Okay, so it is like a fixed bias. Okay, it is a fixed bias. And now see, RC resistor is directly coupled, connected to the collector terminal here. Okay, and VCC is connected to the collector terminal and through the RC. So this is a series fed or directly coupled class A power amplifier. So in this class A power amplifier, first we the definition of the power amplifier is, so what is the power amplifier here? Power amplifier ಇಲ್ಲ sir. Okay, so power amplifier is nothing but the definition is the how much the AC power DC power is converted to the AC power. Okay, the conversion of AC power to DC power. So the efficiency we can call it as PAC by PDC. The formula. The DC power is converted to the AC power. The DC power, the DC input power. So this is you are giving DC input power, no? So this is the DC signal, right? VCC is the DC signal that you are converting into AC signal. So AC signal is nothing but where the output is voice. Voice is nothing but AC signal. Okay. So of course you are giving the AC signal here, and that the power amplifier will process the AC signal in parallel. It will convert the DC signal also into the AC signal. Okay. So it will process the AC signal. As well as the parallel, so it will convert the DC signal also into the AC signal. So the efficiency is equal to PAC by PDC. PAC by PDC. So very important formula for the power amplifiers. Efficiency is equal to PAC by PDC. So the same formula you might have seen in the rectifier. You might have seen the rectifiers that efficiency is equal to PDC by PAC. PDC by PAC. Why? Because there the concept is the rectifier which is used to convert the AC signal to DC signal. Am I right? There the concept is the signal which is converted from AC signal to DC signal. So the PDC by PAC in the rectifier. But in the power amplifiers, it is the process of converting the DC power to AC power. So both are opposite. So the efficiency is equal to PAC by PDC. This efficiency is for power amplifier. That efficiency is for the okay. Of course, but unfortunately, both are indicated with the neta value only. Okay, so don't confuse. So if they're saying that power efficiency PAC by PDC, if they are saying that rectifier efficiency PDC by PA. Okay, so this is the circuit diagram, output waveform, and the definition. Now coming to this, so now we have to calculate what is PAC and what is PDC. Okay, so then we have to calculate the efficiency. So ultimate goal is to calculate efficiency only, no other derivations here. Only the thing is we have to calculate the efficiency. We have to derive the efficiency. That is only the ultimate the objective of this the power amplifiers. So it may be the series fed, transformer coupled, push pull, or complementary symmetry. So we have the four types. So class A, class B power amplifier in the class A 2 and class B also 2. So for all these types, our objective is to calculate efficiency. Okay, so for all these cases, the formula is PAC by PDC only. PAC by PDC only. So from this, PDC is equal to I can write PDC equal to I can write VCC into ICQ. Right. So why? Because so PDC, so DC power. So this is DC power. So what is the DC signal? VCC is the DC signal, and the DC current is IC. Okay. IC is the DC current. So total the product of this one is PDC is equal to PAC. This we can call it as input power. Input DC power. You are giving DC signal as input now, so this is input DC power. AC output power, AC output power is given by is given by, okay, so PAC equal to, there are so many forms like I can write VRMS into IRMS, I can write, am I right? VRMS into IRMS. So this I can convert, into like this. VRMS is nothing but VM by root 2. IRMS is nothing but IM by root 2. Am I right? Everyone? What is the RMS value of the full wave rectifier? RMS value of the full wave rectifier is VM by root 2, IM by root 2. Okay, whereas half wave rectifier వచ్చేసి VM by 2, IM by 2 వస్తుంది. So anyway, it is conducting for 360 degrees conduction angle. So VM by root 2, IM by root 2. So that is equal to, I can write IM, VM, IM by 2. This is PAC. Okay, this is one way. This is equation number 1. Okay, this is one PAC definition. Otherwise, you can simplify it. Still, you can simplify it. I can write IM square by, IM square RL by 2, where VM is equal to IM into RL. Okay, IM square into RL by 2. This is another method. Or VM 2 RL, where IM is equal to VM by RL. Okay, this is the standard. This is the first equation. If we substitute VM is equal to this equation, if you substitute VM equal to this one, you will get this. Or if you substitute IM is equal to this, you will get this. Okay, so VM square by 2 RL. Clear? Still further ఇంకా మీరు ఇంకా ఏం చేయొచ్చు అంటే PAC equal to, again you take VM IM by 2, so VM అంటే ఎట్లా రాయొచ్చు? సో VM is a peak, so that is a peak to peak voltage by 2 కదా, అంతేనా? VM peak voltage అంటే ఎట్లా రాస్తారు? హాఫ్ ఆఫ్ ది పీక్ టు పీక్ వోల్టేజ్ కదా VM అంటే. Yes or no?
Yes, sir.
Yes, sir.
So this is sine wave, let us say. పీక్ టు పీక్ అంటే ఏంటి? ఇక్కడ నుంచి ఇక్కడ దాకా ఉంటుంది పీక్ టు పీక్. ఓకే, సో VM, this is VM. సో VM అంటే ఏంటి? VPP by 2 రాయొచ్చు కదా. Similarly, IM అంటే IPP by 2 by 2. So finally, VPP IPP by 8. Yes or no? VPP into IPP by 8. Okay, fine. So from this you can derive, write what is VPP, how we can calculate VPP. VPP నుంచి ఎట్లా క్యాలిక్యులేట్ చేస్తారు? సో VPP అంటే దిస్ ఈస్ VPP. VPP ఎట్లా క్యాలిక్యులేట్ చేస్తారమ్మా? ఇది 5 volts minus 5. What is the peak to peak voltage here?
10.
10.
Huh? Hello? What is the peak to peak voltage?
10, sir.
10.
No response.
10.
Sir.
Hello?
10, sir.
I'm not getting your voice, or hello?
Yes, sir.
Yes, sir.
Yes, sir.
Hello? Okay. Hello?
Yes, sir.
Okay, done. Can you so what is the answer?
10, sir.
Sorry, 10 volts. So how you are getting the 10 volts?
5 plus
How are you
5.
getting the 10 volts?
Maximum voltage
Adding
and
plus
minimum
Yeah, what is the maximum here?
5.
Okay, what is the minimum?
-5.
So what is the formula now? VPP formula into
V max minus V minimum.
exactly. So VPP is nothing but V max minus V minimum into IPP ante I max minus I minimum divided by 8. It's clear? Any doubts in this?
Yes, sir.
Okay. So VPP is V max minus V minimum into I max minus I minimum by 8. Okay. So this is PAC formula. Now efficiency is equal to neta equal to PAC by PDC is the formula. Am I right? PAC by PDC. What is PAC now? V max minus V minimum into I max minus I minimum by 8 into PCC ICQ. అంతే కదా? Is it clear this step? PAC by
Yes, sir.
PDC రాసేస్తారు. Okay? Fine. So this efficiency, okay, fine. This is the equation of the efficiency. But for maximum efficiency, okay. So from this waveform, this is to go back and see. So this is output waveform here. This is output waveform. What is V max and what is V minimum, I minimum and I max is, no, I will tell you. So for the max efficiency, it just extend the swings to the minimum and maximum. So this is the swings is there, no, that you just extend. So like this, I will show you. So this is the midpoint. This is the midpoint. So like this, minimum అనేది origin point కావాలి, maximum అనేది ఈ DC point దగ్గరికి maximum ఇది I max. This is I minimum. Similarly, this is V minimum. This is V maximum. Okay. This is what VCE IC for just extending that swings. అంటే maximum efficiency రావాలంటే swings అనేది extend చేస్తున్నాం. So from this, what is I max ఏంటి చెప్పండి, ఈ పాయింట్ ఏంటి? దిస్ ఈస్ Q, ICQ comma VCQ. So means this is VCQ, this is ICQ. I max ఏమవుతుంది? See, from
IGQ comma
here
0.
to here, what is this value? ICQ, right? From here to here, అంటే ఇక్కడ ఆరిజిన్ పాయింట్ నుంచి మిడ్ పాయింట్ వరకు ICQ ఉంది. సో ఈ పీక్ మీకు ICQ అంటే ఈ పీక్ ఏమవుతుంది? Hello, please respond. Hello. Hello. Am I audible?
Yes, sir.
Yes, sir.
So this peak is ICQ, right? This peak is because ఇక్కడ బేస్ దగ్గర మీకు ICQ ఉంది. ఇది ICQ అంటే ఇది ఏమవుతుంది? ఇది ICQ నే కదా, right? సో Imax is equal to 2 ICQ వస్తుంది. Imax equal to ICQ plus ICQ 2 ICQ. I minimum equal to minimum అనేది ఇదేంటిది ఆరిజిన్ పాయింట్. సో I minimum is equal to 0. Similarly Vmax is equal to Vmax అనేది ఏంటి ఈ పాయింట్, ఈ పాయింట్ ఏంటిది, ఈ పాయింట్ వాట్ ఇస్ దిస్ పాయింట్, అసలు ఎట్లా మీరు లోడ్ లైన్ ఎలా డ్రా చేశారు గుర్తుందా లేదా ఈ టాపిక్?
VC.
Yes, sir.
VCC మనకి I will go back and I will tell you. VC equal to VCC minus ICRC అనే ఫార్ములా.
Yes, sir.
Yes.
If IC equal to VC equal to VCC. If VCE equal to 0, IC equal to VCC by RL. ఇదేనా మనకి చెప్పాము, ఇది లోడ్ లైన్ అనాలిసిస్ మీకు బీజేటీ యాంప్లిఫైర్ లో చెప్పుకుంటాను.
Yes, sir.
ఈ పాయింట్ ఇక్కడ మార్క్
Yes, sir.
చేయండి, ఈ పాయింట్ ఇక్కడ మార్క్ చేయండి, జాయిన్ చేసేసి స్ట్రైట్ లైన్ డ్రా చేయండి, అదే లోడ్ లైన్ అని చెప్పాను, గుర్తుందా?
Yes, sir.
అంటే ఈ పాయింట్ అనేది VCC పాయింట్, ఇది ఈ పాయింట్ ఏంటి VCC బై RL పాయింట్, ఇది RL ఆర్ RC ఈ పాయింట్. ఓకే, VCC. Vmax ఏంటమ్మా VCC. ఓకే ఓకే, సో VCC. నెక్స్ట్ V మినిమం ఏంటి, V మినిమం ఏంటి, ఈ పాయింట్ ఏంటి V మినిమం?
Zero, sir.
0, రైట్, వెరీ గుడ్. 0. V minimum 0, I minimum 0, Imax to ICQ, Vmax. See, very very important. Any doubts in this? అంటే మీకు Imax ఎలా వచ్చింది, Vmax ఎలా వచ్చింది డౌట్స్ ఉంటే ఇక్కడే క్లారిఫై చేసుకోండి. నెక్స్ట్ ఫ్యూచర్ లో మళ్ళీ ఇదే కాన్సెప్ట్ దీని మీద రిపీట్ అవుతూ ఉంటుంది ప్రతిదీ. ఎనీ డౌట్స్? Imax
No, sir.
ఈ పాయింట్ ఇక్కడ నుంచి ICQ కాబట్టి ఇది ICQ ఉంటుంది. సో Imax is equal to ICQ. I minimum వచ్చేసి ఆర్జిన్ పాయింట్కి వచ్చింది కాబట్టి 0. V minimum కూడా ఆర్జిన్ పాయింట్కి వచ్చింది కాబట్టి 0. Vmax అనేది ఇక్కడ VCC వరకు ఎక్స్టెండ్ చేస్తున్నాం కాబట్టి VCC. ఓకే, సో దిస్ ఈస్ ఫర్ maximum efficiency. These are the 4 things. Now we substitute these 4 parameters in this equation. Substitute 4 parameters in this equation. What will get now? What will get? Neta equal to, I will write again, Vmax minus V minimum into Imax minus I minimum by 8 VCC ICQ. Okay, so Vmax is VCC minus 0 into 2 ICQ minus 0 into by 8 VCC into ICQ. So VCC 2 ICQ 8 VCC into ICQ. ఇప్పుడు ఏమంటే ఎంత వస్తుందమ్మా VCC
1/4.
1/4 అంటే 0.25. ఓకే, సో efficiency is equal to how much? 25%. ఓకే, 25%. సో మీకు కంపారిజన్లో చెప్పాను చూసారా, ఎఫిషియన్సీ ఎంత వస్తుందని చెప్పాను మీకు. కంపారిజన్ ఆఫ్ క్లాస్ ఏ, క్లాస్ బి, క్లాస్ ఏ, బి, క్లాస్ సి ఏదో చెప్పాను కదా, అంతా చెప్పాను మీకు.
25 to 50%.
25 అంటే ఇది సిరీస్ బెడ్కి 25%. 50% ఎప్పుడు వస్తుంది? నెక్స్ట్ ట్రాన్స్ఫార్మ్ కపుల్డ్ ఉంది కదా, ఇంకోటి ఉంది కదా సెకండ్ టైప్ క్లాస్ ఏలో. ఓకే, ఆ ట్రాన్స్ఫార్మ్ కపుల్డ్కి 50% వస్తుంది. ఓకే, that I will tell you. So this is the 25%. And one more parameter we need to calculate, power dissipation. Power dissipation. Power dissipation. So the power dissipation of the transistor is the difference between AC output power to DC input power. Okay, PD is equal to ఇది PDC minus PS. Difference between AC DC input power to AC output power. Okay. The maximum power dissipation occurs when no AC signal is applied. అంతే కదా. ఇప్పుడు పీడీ మ్యాక్స్ ఏమవుతుంది? పీడీ మ్యాక్స్ ఈక్వల్ టు పీడీసీ అవుతుంది. నో ఏసీ సిగ్నల్ అంటే పిఏసీ జీరో. ఏసీ సిగ్నల్ మేము అప్లై చేయాలంటే ఏమవుతుంది? అది జీరో అంటే పీడీసీ వస్తుంది. పీడీ మ్యాక్స్ ఇస్ ఈక్వల్ పీడీసీ వెన్ నో ఏసీ సిగ్నల్ ఇస్ అప్లైడ్. ఇది డీసీ పవర్. ఓకే, సో దిస్ ఈస్ ద clear. Any doubts? Any doubts, please ask. Very very important question. Series fed. ఇది సిరీస్ ఫెడ్ వచ్చేసిందంటే నెక్స్ట్ ట్రాన్స్ఫార్మ్ కపుల్డ్ డెడ్ ఈజీ. అదేం ఉండదు. ఓకే, సో ఇక్కడ వరకు అంతా సేమ్ వస్తుంది. ఓన్లీ థింగ్ ఏంటంటే ఇక్కడ కొంచెం డిఫరెన్స్ వస్తుంది. ఇక్కడ ఈ పార్ట్ లో కొంచెం డిఫరెన్స్ వస్తుంది అంతే. మిగతా అంతా సేమ్ టు సేమ్. కాపీ పేస్ట్. Any queries? Can I move to the next topic?
No, sir. Yes, sir.
Yes or no?
Yes, sir.
Okay.
Yes, sir.
Okay. Next, to take the heading transformer coupled class A power amplifier. Transformer coupled class A power amplifier. Okay, you need any break? And 3-4 hours also I'm going to take 3-4 hours also. If you want any break, I will give you. Otherwise, I'll continue. So Murali Prasad sir will take in the afternoon session. Any break you want? I think not required. Okay, fine. Okay, so these so I will draw the circuit. Okay, so before starting this, I forgot to tell disadvantages are so please okay, I will tell you the disadvantages or advantages and disadvantages, then I will move to the next one. Now, what are the advantages of this? Advantages. Circuit is simple to design. So because we required only two transistors, one RP resistor, two resistors, one RP and RC, one simple power transistor. and cheaper, costly wise. Third one is less number of components are required. Okay, so that is circuit is simple, and this and the less number of components required. These are the advantages. Disadvantages are, okay, tell me what are the disadvantages?
Low efficiency.
Less efficiency.
Yes, low efficiency. Okay, next. Next entity, efficiency is low, and next power dissipation is more. Why? Because when though you're not applying any AC signal, also it causes some power dissipation. Am I right? So the PD max is equal to PD max equal to PDC. So the maximum power dissipation occurs when no AC signal is applied. అంటే ఏంటి? AC signal మీరు అప్లై చేయకపోయినా మీకు పవర్ అనేది some waste అవుతుంది. So the power dissipation is more. And the third point is, and the output impedance cannot match with the input impedance. Output impedance cannot match with input of the loudspeaker. Why? Because ఇక్కడ లోడ్ లో ఏం వాడుతున్నారు చూడండి, సర్క్యూట్ ఏం వాడుతున్నారు ఇక్కడ, వాట్ ఇస్ RC రెసిస్టెన్స్ వాడుతున్నాం. సో RC రెసిస్టెన్స్ అనేది ఇట్స్ వాట్ వి కాల్ రెసిస్టెన్స్. సో వాట్ వి ఆర్ కనెక్టింగ్ ఎక్స్టర్నల్లీ. సో ఇక్కడ నుంచే కదా ఇది పవర్ యాంప్లిఫైర్, ఇక్కడ నుంచే కదా మీ లౌడ్ స్పీకర్కి ఇస్తారు, ఇదే కదా లౌడ్ స్పీకర్ ఇచ్చేది అవుట్పుట్. సో ఇక్కడ వచ్చేసి ఏముంటుంది, 5 ohms నుంచి 20 ohms రేంజ్ ఉంటుంది. బట్ RC అనేది ఇన్ టర్మ్స్ ఆఫ్ కిలో ohms, దట్ ఇన్ టర్మ్స్ ఆఫ్ కిలో ohms. ఓకే, so this impedance matching problem occurs. So 1 kilo ohm resistor cannot match with the 5 ohms to 20 ohms. So there is a impedance problem. Okay, so output impedance cannot match with the input impedance of the input of the loudspeaker, input impedance of the loudspeaker. Okay, so these are the 3 disadvantages we found in the this one. Now the classic power amplifier. One is the efficiency is less, power dissipation is more, output impedance cannot match with the input impedance of the loudspeaker. Okay, so now take the heading transformer coupled. Now transformer coupled class A power amplifier. Class A power amplifier. Okay, so in this, so to overcome the problems which we faced in the class A power amp series FET, so we are drawing 1 minute. Okay, so to overcome those problems which we face in the class A power amplifier, we are coming to transform coupled. So now circuit is the same circuit. Okay, so this is we are replacing the RC resistor with the transformer. The only difference is same circuit diagram. We are replacing RC resistor with transformer. So here the voltage is V1, here it is V2. Okay, and so this is the load resistance RL, and this is RL dash. This is RL dash. I will tell. This is RL. Okay, so I will redraw this remaining portion, the transformer coupled separately. So I will also the same circuit. Okay, so transformer. So this is V1. This is V2. This is I2 current. This is I1 current. Right. This is the RL load resistance. Here it is RL dash, RL. Okay. So I hope you know that the relationship between the turns ratio to, so this is N1 and this is N2, N1 and N2. So where turns ratio N is equal to, I can write it as N2 by N1. And the relation between the voltage, primary voltage to secondary voltage is V1 by V2 by V1 is equal to N2 by N1. I2 by I1 equal to N1 by N2. Okay, so these relations, the turns ratio to current and voltages, right? And from this I can write, RL dash equal to RL by N square. RL by N square. Okay, so these are the relations of voltages, currents, and the turns ratio. Okay, so this is the turns ratios. And coming to the waveform, output waveform for this class, class A for transform coupled class A for amplifier, the same waveform. So for what we have for class A was series fed. Series fed waveform on the same waveform. Both are class A power amplifiers only. Both are for 360 degrees conduction angle only. Everything is same. Okay. So now coming to DC input power. In DC input power. What is the formula? VDC equal to VCC into ICQ. Same as our series fed. VDC equal to VCC into ICQ. Next, AC output power. AC output power. So PAC equal to, okay. So PAC equal to M Rasam P VRMS into I RMS Rasam. Okay. So RMS, right? So now here there are the primary and secondary only. Okay, so primary, why? Because if the transformer, this is a primary and this is a secondary. Okay, so the voltages what we take is the primary voltage we are taking V1 RMS, I1 RMS. V1 RMS is the primary RMS voltage. I1 RMS is the primary RMS current. Primary RMS current and the primary RMS voltage. Okay. Similarly, suppose if you take a V1 RMS into RMS value of primary voltage. Okay. V2 RMS into RMS value of secondary voltage. Or I1 RMS into RMS value of primary current. I2 RMS అంటే RMS value of secondary. Okay, secondary current, right? So these are the definition. So PAC place lo you can take V1 RMS or I1 RMS, your wish. Even you can take V1 RMS and IRMS. Generally will take the primary. They are convert of the primary only, we are converting to the secondary. So we'll take PAC equal to V1 RMS into I1 RMS. So PAC equal to what? PAC equal to V1 RMS ఎట్లా రాయొచ్చు? V1 M by root 2 I1 M by root 2. One indicates primary peak voltage, primary peak current. Okay, whereas the class pedle మీకు సిరీస్ pedle ఏం చేసాము, there are no primary and secondary, only ఒకటే స్టాండర్డ్ ఉంటుంది కాబట్టి V1 VM IM రాసాము. ఇక్కడ primary secondary ఉంది కాబట్టి V1 we are indicating with what letter 1 or second. Okay, so this V1M I1M by 2. Okay, or I can write V1 square by V1M square by 2 RL dash, or I1M square into RL dash by 2. So all are same. So suppose if you substitute VM is equal to IM into RL dash, you will get this. If you substitute IM is equal to VM by RL, you will get this. So all are same. All are some ఒకదాని నుంచి ఒకటి మీకు ఇంటర్లింక్ అయ్యింది. Okay, so from this VM అంటే ఏం వస్తుంది again? VM అంటే VPP by 2 into I ante IPP by 2 divided by 2. So similarly VPP IPP by 8. సేమ్ మీ క్లాస్ ఏ పవర్ యాంప్లిఫైర్ సిరీస్ ఫెడ్లో ఎలా అయితే చేసామో సేమ్ చేసుకుంటే వెళ్ళాలి. ఓన్లీ ఏంటంటే ప్రైమరీ అక్కడ విఎం ఐఎం అని చోట V1M I1M పెట్టాలి అంతే. మిగతా సేమ్ టు సేమ్. పిఎస్సి VPP IPP 8. ఓకే, పిఎస్సి VPP అంటే ఏంటి? Vmax minus Vminimum into Imax minus Iminimum divided by 8. Okay, so this is PAC. So efficiency formula enti? Efficiency is neta equal to PAC by PDC, that is equal to Vmax minus Vminimum into Imax minus Iminimum by 8 VCC ICQ. Okay, so this is efficiency. Next, maximum efficiency formula enti? Maximum efficiency ki, okay, so now coming to the point. Okay, now coming to the point, max efficiency ikkada meeku difference vastundi. I minimum, V minimum, V max, I max. Okay, this point is IC. Okay, so from this I max is equal to what? You can ఈ peak వచ్చేసి ICQ peak, ఈ peak వచ్చేసి ICQ. ఈ peak ఏమవుతుంది? I max ఏమవుతుంది? Another ICQ. So I max is equal to what? What is I max?
2 ICQ.
Okay,
2
ICQ.
ICQ.
I minimum
0.
0. Okay.
0.
V max, V max ఏంటి? Okay, we'll talk about V minimum ఏంటి?
0.
0. Okay. So I max 2 ICQ same, I minimum same, V minimum same. Okay, ఎంతవరకు సేమ్ మీ క్లాస్ సిరీస్ ఫెయిట్ క్లాస్ అయితే సేమ్. Now the problem is V max. V max ఈ పాయింట్ ఏంటమ్మా? ఈ పాయింట్, this point is VCC. Okay. Now in this, so what is this voltage? What is this? This is VCQ నే కదా? Right? So Q point is VCQ. So for transformer coupled class A power amplifier, what is the basic formula? VCE equal to VCC minus IC into RL or RC. Is that the basic formula? Yes or no?
Yes, sir.
ఇప్పుడు ఈ ట్రాన్స్ఫార్మ్ కపుల్డ్ క్లాస్ ఏ పవర్ యాంప్లిఫైయర్, వాట్ అబౌట్ దిస్ RC? So RC you replace with the transformer. RC you replace with the transformer. So here the RC is nothing but RL dash. Okay, so here what happens is this is very small in terms of ohms. Okay, why? Because your transformer use చేస్తారు కదా. ఇప్పుడు now we are using transformer, you are converting that resistance into the lower resistance. అంటే మీకు ఇంపెడెన్స్ లౌడ్ స్పీకర్ కి ఇంపెడెన్స్ మ్యాచ్ అయ్యే విధంగా we are converting using the turns ratio. So if you have 1 kilo ohm resistor, that can be converted into in terms of 5 ohms or 10 ohms, depends on the input impedance of the loudspeaker. So this is very, very small. This load speaker is this load resistance is very, very small. So you are taking the transformer entity. The transformer has also the resistance impedance into the transformer, but how much that is in terms of the ohms. So this is in terms of milliamperes. This is in terms of few ohms. Let us say 5, and the total ఎంత వస్తుంది? 10 millivolts వస్తుంది. Total will get 10 millivolts. Compared to VCC, 10 millivolts is very, very small amount, right? VCC ఎంత 12 volts ఇది. Minus 10 millivolts అంటే ఎంత వస్తుంది? Approximately equal to 12 volts కదా. Approximately equal to. So this portion gets eliminated. So VCE is equal to approximately equal to VCC ne. VCE equal to minus VCC. So this is 1 VCC. This is 1 VCC. అప్పుడు ఇదేమవుతుంది? 2 VCC అవుతుంది. Okay, so Vmax is equal to 2 VCC. You got my point? Okay, so
Yes, sir.
సిరీస్ ఫెడ్ లో VCE equal to VCC minus ICRC ఉంటుంది. ఇది సిరీస్ ఫెడ్ లో. దానిలో మీకు లోడ్ కెపాసిటెన్స్ రెసిస్టెన్స్ ఉంటుంది. సో అది 1K నో 2K నో ఎంత ఉంటుంది, దాన్ని బట్టి మీకు 1K అన్నా కానీ మీకు 1 volt or 2 volts ఎంత వస్తుంది. ఓకే, సో దానివల్ల మీకు అవుట్పుట్ అనేది సమ్ డీవియేషన్ అవుట్పుట్ యూ మైట్ హ్యావ్ గెట్ 10 volts రావచ్చు, బట్ మీకు ఏమి ప్రాబ్లం వల్ల సో 10 లేకపోతే 8 or 7 సంథింగ్ అట్లా ఏదో వస్తుంది. But now the problem with RC is, so this is not used for the impedance matching. That is a disadvantage in the series fed class A power amplifier, and the efficiency is less. So because by keeping all these disadvantages in our mind, we are moving to the transform coupled class A power amplifier. In the transform coupled class A power amplifier, we are replacing this RC by the transformer, which has a very low impedance. So because compared to the VCC, this is negligible amount, you can remove it. So VC equal to VC subtract. So this point itself a VCC, this Q point well itself a VCC. So this is we can write as VCC. ICQ comma VCC. So if it is VCC and this Vmax becomes 2 VCC. Okay. So Imax equal to 2 ICQ, I minimum equal to 0, Vmax equal to 2 VCC, V minimum equal to 0. Any doubts in this?
Please extend one more.
Yeah. So for class the basic equation. Basic equation is VCE equal to VCC minus IC into RC ఉంటుంది. Okay, series fed class A power amplifier, we have RC resistor, that is 1K or 2K, so depends, but it is in terms of kilo ohms. Okay, so our kilo ohms is, so IC is equal to, if you take 2 milliamperes, if you take RC is equal to 2 kilo ohm, and that K milli gets cancelled, 2 2s are 4, అంటే 12 minus 4 అంటే you're getting 8 volts వస్తుంది మీకు అవుట్పుట్ లో. Okay, VC equal to 8 volts, which is not equal to your 12 volts. So 12 volts రావాల్సింది మీకు 8 volts వస్తుంది. That is because of RC resistor. So we are losing the information. So that is the reason we are getting efficiency is 25%. So now what we are doing, we are replacing that RC with a transformer. We are placing the transformer wherever it is the RC resistor. So RC resistor lo meeku transformer replace cheyadam valla the transformer is replaced in terms of RC, which has very low impedance value. It has very low impedance. Suppose inductor తీసుకున్నామా, ఐడియల్ ఇండక్టర్ కి ఇంపెడెన్స్ ఎంత ఉంటుంది? ఐడియల్ ఇండక్టర్ కి ఇంపెడెన్స్ ఎంత ఉంటుంది? ఈ ట్రాన్స్ఫార్మర్ అంటే ఏంటి? 2 ఇండక్టర్స్ అనే కదా, మ్యూచువల్ ఇండక్టెన్స్ ఉంటుంది. సో ఐడియల్ ఇండక్టర్ కి రెసిస్టెన్స్ అనేది చాలా తక్కువ ఉంటుంది, 0. బట్ ప్రాక్టికల్ గా ఇట్ హ్యాస్ సమ్ ఉంటుంది కదా, బట్ దట్ ఈస్ ఇన్ టర్మ్స్ ఆఫ్ ఓమ్స్. సో ఇప్పుడు now coming to the with respect to that transform couple, VC equal to VCC minus IC RL dash. So this is very less in terms of 5 ohms or 10 ohms, and this is 2 milliamperes. You multiply 2 5 is 10 millivolts. So this is 12 volts minus 10 millivolts is very negligible amount you can remove. So VC equal, it approximately equal to VCC here. Okay, this is not the case with series FET. Okay, so that is the reason ikkada meeku Q point anedi ICQ comma VCQ. So VCQ ante VCC ne kada, so I am replacing ICQ comma VCC రాస్తున్నాను. ఇది VCC అంటే ఇది ఈ పీక్ VCC, ఈ పీక్ ఏమవుతుంది? ఇంకో VCC ఉంటుంది కదా. This VM is VCC, another VM is also VCC. Total becomes 2 VCC. So Vmax equal to 2 VCC అవుతుంది. ఓకే, సిరీస్ ఫెట్ లో వచ్చేసి Vmax equal to 1 VCC నే, బట్ ఇక్కడ 2 VCC అవుతుంది. దట్ ఈస్ బికాస్ ఆఫ్ absence of your load resistance. Clear? Varun, it's clear?
Yes, sir.
So now efficiency is equal to, again I will write formula, Vmax minus V minimum into Imax minus I minimum divided by 8 VCC ICQ equal to Vmax is 2 VCC minus 0, 2 ICQ minus 0, 8 VCC into ICQ. So 2 VCC into 2 ICQ divided by 8 VCC into ICQ. So the result is 1/2. So 0.5 percentage efficiency is equal to 50%. Clear? See, the series FET class and series FET class A and transformer, only the difference is here. ఇక్కడ ఒక్కటే డిఫరెన్స్, మిగతాదంతా సేమ్. కాపీ పేస్ట్ అంతా సేమ్. Okay, so this is 50%. Okay, but practically it is 30 to 35% ఉంటుంది ప్రాక్టికల్గా. వేరాజ్ సిరీస్ ఫెట్ వచ్చేసి 10 to 15% ఉంటుంది ప్రాక్టికల్. 10 to 15% ప్రాక్టికల్లీ. ఇక్కడ వచ్చేసి 30 to 35% ఉంటుంది. ఓకే, రైట్. నెక్స్ట్, power dissipation. Same as a series FET. PD equal to PDC minus PAC. When no AC signal applied, the maximum power dissipation occurs. That is PD max equal to PDC. PD max equal to PDC. So advantages. One is what are the advantages? Advantages ఏంటి? క్లాస్ ఏలో సిరీస్ ఫెడ్ డిసడ్వాంటేజెస్ ఏంటి?
Lowest efficiency,
ఇక్కడ ఎంత వచ్చింది ఎఫిషియన్సీ?
50% increased.
So better efficiency compared to series fed class A power amplifier. Still the efficiency has to be increased, but compared to series fed class A power amplifier, it is good. And next disadvantage enti? Class A power amplifier lo series fed lo disadvantage enti? Second disadvantage.
Power dissipation is more.
Ikkada kuda power dissipation is more. Same formula kada. So that is not overcome here. Next impedance matching. Ante kada third point, impedance matching is not possible there. Ante kada?
Yes, sir.
So here impedance matching is possible through transformer. Impedance matching is possible through transformer. Disadvantage enti?
Bulky circuit.
Yes, exactly. Bulky because you are using transformer. Next.
Costly.
Yeah, bulky and costly. Okay. Complicated to design. It's not so easy to design like series fed, and frequency response is poor. So remember, whenever the transformer is there in the circuit, it affects your frequency response. Okay. So these are the disadvantages, advantages and disadvantages. Okay. Clear? Any doubts? Right. Next, now down comparison, series fed versus transformer coupled, and tell me the points. Comparison table is ending. Comparison table is చెప్పండి. First point ఏంటి?
Less efficient.
Low efficiency.
Efficiency.
Efficiency less దేనికి?
Series fed.
Okay, series fed efficiency is 25%. Transfer coupled వచ్చేసి
50.
Okay, 50%. Fine. Next difference ఏంటి? Next difference ఏంటి?
Impedance matching.
Impedance
Impedance
match
matching.
not possible in series fed.
Series fed.
Series fed it is not possible. Transfer couple it is possible. Okay, ఇంకా ఇంకేంటి
Complicated circuit.
సింపుల్ టు డిజైన్ ప్లస్ సిరీస్ ఫెడ్, కాంప్లికేటెడ్ టు డిజైన్ ట్రాన్స్ఫార్మ్ కపుల్డ్. ఓకే, ఇంకా frequency response is better in series fed, frequency response is poor in transform coupled. Frequency response is better in series fed, frequency response is poor in transform coupled. Okay, next, still any other differences? Classic series fed, load is directly connected to the collector, so transformer is not required. Series fed, load is directly connected to the collector, so transformer is not required. Load is directly connected to the collector, so transformer is not required for series fed. And transfer coupled వచ్చేసి output transformer is required. Output transformer is required. Okay, fine. So the next, so this is about class A power amplifiers. Next, take the heading, class B power amplifiers. Class B power amplifiers. Okay, so class B power amplifiers. So in general, so coming to the class B, okay, so for class A power amplifier, the conduction angle is 360 degrees. So need not to do any other parameter, other techniques, or need not to apply any other procedures to get the 360, because basically class A power amplifier is giving 360 degrees, but a class B power amplifier is giving only 180 degrees conduction angle. Okay, so to compensate another 180 degrees conduction angle, so basically class B is only 180, but to compensate another 180 degrees conduction angle, here we are compensating with another transistor. So class B power amplifier consists of the two transistors. So one transistor for 180, another transistor for another 180. So together again becomes 360. So this is just a compensation. So though you are getting class B also full cycle, you are not supposed to tell that what is the conduction angle for the class B and 360. And you are not supposed to tell. Class B conduction angle is always 180. Okay, but we are compensating. We are by taking another transistor to the circuit diagram. We are compensating with another transistor. So that we'll get the full cycle. Okay, so that is the difference. So 1 minute, I will come back. Yeah. So because of the basic definition of the class B power amplifier, it gives a whole conduction angle is 180 degrees, but to compensate another 180 degrees conduction angle, so we are using another transistor, so which get another half cycle. Okay, so based on, so now we came to know that, so there are two transistors in the class B power amplifier. The two transistors in the class B power amplifier. Is my screen visible?
Yes, sir.
So what it is displaying?
Class B power.
Class B power amplifier.
Okay, so fine. So based on this, so we are going to take the two transistors. So now depends on the selection of. So this depends on the selection of the transistor. The class B is defined. Class B power amplifier is classified two types. That is, if both the transistors are the same type, if both the transistors are opposite types. Like depends on that. So we are classifying with there are the two types. That is push pull class B power amplifier, and second one it is complementary symmetry class B power amplifier. Okay, so push pull amplifier and class B complementary symmetry. So based on the selection of the transistor, when both the transistors are of same type, either NPN or PNP, then the circuit is called push pull. The push pull class B ante both the transistors should be same type, either NPN transistors or PNP transistors, but both should be same type. If both the transistors are opposite type, like one transistor is NPN transistor, another transistor is PNP transistor, then we'll call it as the complementary symmetry class B power amplifier. Okay, so only the depends on the selection of the transistor. It is classified two. Only that depends on the two. So only thing is what we call if both are same type, either NPN or PNP, that is a push pull class B power amplifier. If one is NPN transistor, other is a PNP transistor, then it is to be this one, the complementary symmetry. Okay, so first let me take push pull class B power amplifier. class B, push pull class B power amplifier. Okay. Push pull class B power amplifier here. I'm drawing the circuit.
గ్రాడ్ అయినాడు అబ్బా.
Okay, drawn, circuit drawn, completed.
Yes, sir.
Okay, so this push pull class B power amplifier. Now see, I'm taking both NPN transistor, NPN this is, and see the NPN transistor. See the arrow mark of the emitter. It is coming out of the transistor, so it is NPN, NPN, NPN. So if both are NPN transistors, if you have to take plus VCC. If both are PNP transistor, you have to take minus VCC. That is the difference. If you take both are NPN transistor, positive supply we have to take. If both are PNP transistor, negative supply we have to take. Okay, that is only the difference. Now, input, there are the two transformers are here. One is input or driver transformer. Output is the second one is the output transformer. So the signal will be derived for the input and applied to the Q1 and the Q2 transistors, and output transformer is used to the send the to match the impedance to match the impedance for the loudspeaker, input of the loudspeaker. So these two inputs. So input transformer is used to drive the signal. Output transformer is used to match the output impedance with the input impedance of the loudspeaker. These are the two important things. And one more difference is, for NPN transistor we have to take plus VCC. PNP transistor we have to take PNP negative supply minus VCC. Okay. Now see the constructions here. The constructions. So see, this is emitter is connected to the ground, and here also emitter is connected to ground. This is emitter is connected to ground. Here also emitter is connected to ground. So input is applied to the base, output is applied to the base here, and output is collector, and output is also collector. So means this is one CE configuration. This is a CE configuration. This is also CE configuration. Okay. So we are taking CE configuration for push-pull class B power amplifier. Even you can take the class B also, that CB also. You can take CB amplifier also. Not it's not only mean for we have to take only C amplifier. You can take CB amplifier also. And we are taking for CB amplifier, but the problem is output impedance is high. Okay, output impedance is high for the CB amplifier, but the loudspeaker input impedance is low. The loudspeaker is input impedance is low. So to match these impedances, anyway we are using the transformer, no? So that's not a problem. You can connect the CB also. Anyway you are using the transformer, so that can convert high impedance to the low impedance. Okay, so in the place of CE you can use the CB amplifier also, no issue. Okay, so this is the class B. And now coming to the operation. So now let us see, this is the positive peak I'm giving. This is the positive peak. If you give the Q1, this transistor will be on, and okay, this transistor will be on at the same time period. At the same time period, we are giving the negative peak here. In the same time period, we are giving the negative peak. So this will be off. So for let us assume that so 0, T1, T2. For 0 to T1, Q1 is on, Q2 is off. Okay. So for T1 to T2, Q1 is off, Q2 is on. So the positive peak of Q1, the positive peak of this positive peak will be processed through the transistor in between 0 to T1 here. That positive peak will be processed here in between T1 to T2. So here on positive peak and here on positive peak, two positive peaks will appear in the output. Therefore, so it comes to 360-degree. It's completely our full wave rectifier operation. Full wave rectifier operation, completely full wave rectifier operation. Okay. So the like that it will operate. Full wave rectifier, one positive Q transistor 0 to T1 Q1 on avutundi. So positive peak will be processed here, and the Q2 will be off. And the T1 to T2 వచ్చేసి Q1 ఆఫ్ అవుతుంది, ఇక్కడ ఒక పాజిటివ్ పీక్ ప్రాసెస్ అవుతుంది. సో యాడ్ చేసేస్తే టోటల్ విల్ గెట్ 360-degree conduction angle. Okay, so this is the push-pull class B power amplifier. And now coming to the efficiency calculations. So efficiency calculation, what is the first one? DC input power we have to calculate. Input power PDC equal to VCC into ICQ or IDC. So now in this VCC into ICQ is what? ICQ is nothing but IDC. Let us say that the DC current only, no? So the IDC. So this operation is full wave rectifier operation, right? This operation is full wave rectifier operation. What is the value? What is the value of IDC for full wave rectifier? 2m by pi, right? Full wave rectifier IDC is equal to 2m by pi ane kada.
Yes, sir.
Yes, sir.
Im by pi. So therefore you'll get 2 VC Im by pi. Next, AC output power. AC V1M by 2. Actually V1 RMS into I1 RMS.
Disturbance.
Is it okay now?
Still we are getting.
Still you are getting. Now check it.
Now it is okay, sir.
Okay. So actually PS equal to V1 RMS into I1 RMS. So V1 RMS is V1 by root 2 and I1 is IM by root 2. Okay. So this you will get it VM IM by. So here I will keep the content same. I am not going to change that VPT by 2 and IP2 by 2 so that Vmax minus I minimum Vmax change. Anyway, PDC is in terms of IM, no? PDC is in terms of IM. So PA is also in terms of IM. So both gets cancelled. So I'm not changing anything. If you want, you can write it. If you want, you can write VM square by 2 RL dash or I1M square into RL dash by 2. You can write it if you want. But anyway, PDC is in terms of IM, no? So both gets cancelled. So I'm not changing anything here. So this is a second point, and third point is efficiency neta equal to PAC by PDC, that is equal to V1M I1M by 2 into, so PDC in the denominator, no, so it comes pi by 2 VCC IM. IM cancel, IM cancel. So neta equal to pi by 4 V1M by V2. This is the formula efficiency. Pi by 4 into V1M by V2. Okay. For maximum efficiency,
Sir, we are getting disturbance, sir.
for maximum efficiency, go to the output waveform. This is the load. Now it's clear.
Yes, sir.
Okay, this is VCC. This is VCC. Extend the swing. అంటే ఇక్కడ దాకా స్వింగ్ ఎక్స్టెండ్ చేయాలి. ఓకే, ఇదే కదా మీకు అవుట్పుట్ వేవ్ ఫామ్ వచ్చేది క్లాస్ బిలో. ఓన్లీ ఒక పీక్ మాత్రమే ప్రాసెస్ అవుతుంది, నెక్స్ట్ పీక్ వచ్చేసి కట్ అవుతుంది. ఓకే, మరి ఇంకో ట్రాన్సిస్టర్ వాడాం కదా, సెకండ్ పీక్ కూడా ప్రాసెస్ అవుతుంది అంటే కాదు. దాన్ని కంపన్సేట్ చేయడం కోసం మనం ఏదో దాన్ని ఏమంటామో మాన్యువల్గా చేస్తున్నాం. But we are not changing the operation of a class B power amplifier. We are not changing the definition of the class B power amplifier. ఇది మాన్యువల్గా టెంపరీగా ఈ కంపన్సేషన్ కోసం చేస్తున్నాం కానీ, బట్ వీఆర్ నాట్ చేంజ్. సో నౌ సీ ద అవుట్పుట్ వేవ్ ఫార్మ్ ఆఫ్ యువర్ క్లాస్ బి పవర్ యాంప్లిఫైర్ లైక్ దిస్. ఓకే, ఇక్కడ ద క్యూ పాయింట్ ఈస్ లైస్ ఆన్ ఎక్స్ యాక్సిస్ కదా, ఇక్కడ మీరు సిగ్నల్ అప్లై చేస్తారు. పాజిటివ్ పీక్ ఒకటి ప్రాసెస్ అవుతుంది, నెగిటివ్ పీక్ అనేది క్లిప్ అవుతుంది. ఓకే, సో ఫ్రమ్ హియర్ టు హియర్ వాట్ ఈస్ దిస్ వాల్యూ? దిస్ ఇస్ సింగిల్ పీక్ కదా, విఎం. Am I right? So this VM. So now max extend చేసి ఇక్కడ 0, ఇది VCC. So VM is equal to what? VCC అవుతుంది కదా ఇక్కడ. Am I right? If you extend the swing, VM is equal to VCC నే కదా.
Yes, sir.
Yes,
So
sir.
now neta equal to pi by 4 into VCC by VCC. So gets cancelled. So neta equal to pi by 4. What is the value? Pi value is 3.14 by 4 something. What is the value? Tell me.
0.78.
0.785 వస్తుంది. Okay, therefore the efficiency percentage efficiency equal to 78.5%. 78.5%. ఓకే, ఇదేనమ్మా. ఇది జస్ట్ మీరు ఇవే క్యాలిక్యులేషన్స్ మనం చేయాల్సింది. క్లాస్ ఏ పవర్ యాంప్లిఫైర్ కానీ క్లాస్ బి పవర్ యాంప్లిఫైర్ కానీ వీ హ్యావ్ టు క్యాలిక్యులేట్ పవర్ ఎఫిషియన్సీ అండ్ ద పవర్ డిసిపేషన్. మీరు క్లాస్ ఏలో 2 టైప్స్ ఉంటాయి, క్లాస్ బిలో 2 టైప్స్ ఉంటాయి. బట్ ఏ టైప్ అయినా కానీ మనం చేయాల్సింది ఇదే. ఓకే, ఎనీ డౌట్స్ ఇన్ దిస్? But practically it is it is 65 to 70% ఉంటుంది ప్రాక్టికల్గా అయితే. Okay, now power dissipation. Okay, so what is the formula? Power dissipation formula ఏంటి? What is the formula?
PDC minus PAC.
PD equal to PDC minus PAC. So PDC formula ఏంటి? 2 VCC IM by pi minus VM square by 2 RL dash. ఇదే కదా ఫార్ములా. PAC అంటే VM square by 2 RL dash and PDC అంటే VCC into IM by pi. So this I can write 2 VCC by pi. IM అంటే ఏంటి? VM square by RL dash. Sorry, VM by RL dash minus VM square by 2 RL dash. Okay, so now coming to, so actually manaku class A power amplifier em cheppa, when no AC signal is applied, PD is the PD max. Am I right? So PD max is equal to PDC. Now if you apply, so when no AC signal is applied, when no AC signal is applied ante VM is 0. Okay, so VM is 0, so this becomes, this term will be 0, this term also will be 0, and what is the power dissipation?
0.
Power dissipation 0.
0.
So the power dissipation is 0 means this is not power maximum power dissipation. So but the advantage of this class B power amplifier is when no signal is applied, when no AC signal is applied, power dissipation is 0. Power dissipation is 0. This is advantage. This is advantage compared to the class A power amplifier. But class A power amplifier అంటే AC signal మీరు అప్లై చేయకపోయినా మీకు పవర్ డిసిపేషన్ అనేది PDC వస్తుంది. But in the class B power amplifier, when no AC signal is applied, power dissipation is 0. Okay, now how to calculate maximum power dissipation? Now this is not maximum power dissipation. Okay, so the maximum power dissipation can be calculated by doing differentiate power dissipation with respect to Vm and equal to 0. Differentiate power dissipation with respect to Vm and equal to 0. So now differentiate చెప్పండి ఫస్ట్ ది ఏమవుతుంది differentiation of PD చెప్పండి
2 VCC by pi RL dash
okay
minus 2 VM by 2 RL dash.
okay equal to 0. 2 VCC by pi RL dash minus equal to 2 VM by 2 RL dash. Okay, RL dash cancel, 2 cancel. So Vm is equal to 2 VCC by pi. 2 VCC by pi. Okay, so now substitute Vm value in PD equation. So PD equal to 2 VCC by 2 VCC by pi RL dash into 2 VCC minus Vm square కదా అది Vm square అన్న Vm square అంటే minus 1 by 2 RL dash into 2 VCC by pi whole square. So what is 4 VCC square by pi square RL dash minus ఇది ఎంత వస్తుందమ్మా 1 by 2 RL dash into 4 VCC square by pi square. Okay, so that is equal to 2 1s are 2 2s are RL dash minus 2 VCC square by pi square RL dash. So PD max equal to 4 minus 2. The remaining portion is everything same. 4 minus 2, 2 VCC square by RL dash. Okay, so దీన్ని name రాస్తున్నా అంటే 4 by pi square into VCC square by 2 RL dash రాస్తున్నా. Okay, 2 RL dash. So this I can write it as 4 by pi square into PAC max. Okay, what is the formula for PAC? What is the PAC formula ఏంటి? PAC
VRMS
formula ఏంటంటే Vm square by 2 RL dash ఏనా?
Yes, sir.
So here PAC max equal to VCC square by 2 RL dash, that is Vm is equal VCC. Maximum power dissipation రావాలంటే Vm ఏమనుకున్నాం maximum power dissipation కి maximum
2
power
VCC by pi.
maximum efficiency కి Vm is equal to VCC కదా.
Yes, sir.
Right?
Yes.
So PAC equal to Vm square by 2 RL dash, that is equal to VCC square by 2 RL dash. So in the place of here I am substituting this. Okay, so PD max finally PD max equal to 4 by pi square into PAC max. Okay, this is for how many transistors you are using in this class B? How many transistors are using in class B power amplifier?
2, sir.
Two
టూ
transistor.
ట్రాన్సిస్టర్స్ వాడితే పవర్ డిసిపేషన్ 4/π² అంటే పిఎస్సి మ్యాక్స్ వస్తుంది. అదే ఒక ట్రాన్సిస్టర్ వాడితే 2/π² 2 కదా. ఓకే, సో నోట్ పాయింట్ నోట్ ఫర్ maximum efficiency Vm is equal to VCC. For maximum power dissipation Vm equal to 2 VCC by pi. So remember, both are Vm only, but maximum efficiency రావాలంటే Vm is equal to VCC substitute చేయాలి. maximum power dissipation రావాలంటే Vm is equal to 2 VCC by pi substitute చేయాలి. ఓకే, maximum efficiency అంటే Vm by VCC. ఓకే, ఫర్ maximum power dissipation అంటే Vm equal to 2 VCC by pi. Understood? Any doubts in this?
No, sir.
Okay, next note down. Sorry. Next is heading complementary symmetry. Complementary symmetry, class B power amplifier. Okay, okay, so now see, this is complementary symmetry class B power amplifier. So see, this one is NPN transistor, another is PNP transistor, two opposite types of transistors we are using. For NPN we are using plus VCC, for PNP we are using minus VCC. Okay, now coming to this configuration, what is the configuration of it? What is the configuration? Input you are giving to the base, output is taken across the emitter. Output ekkada emitter kada తీసుకున్నారు, ఇది emitter, ఇది emitter. Output is taken across the emitter and the collector is connected to the ground. Collector is connected to the supplies. Here collector is connected to supply. Supply anyway in the AC analysis, all DC sources connected to ground. H parameter model lo cheppam kada, all DC sources should be connected to ground when you are doing the AC analysis. Okay, so means collector is connected to the ground. This is ground, and this is also ground, and this is input base, output is emitter. Now what is the configuration of it? ఏ కాన్ఫిగరేషన్ వాడుతున్నాం ఇక్కడ?
సిబి
ఇన్పుట్ బేస్, అవుట్పుట్ ఎమిటర్, కలెక్టర్ గ్రౌండ్. సిసి కామన్ కలెక్టర్ కాన్ఫిగరేషన్ వాడుతున్నాం. ఓకే, ఫర్ కాంప్లిమెంటరీ సిమెట్రీ క్లాస్ బి పవర్ యాంప్లిఫైర్ యు ఆర్ ఫోర్స్డ్ టు యూస్ కాంప్లిమెంటరీ కామన్ కలెక్టర్ ఓన్లీ. వేరాస్ పుష్ పుల్ వచ్చేసి మీరు ఏ సి యాంప్లిఫైర్ వాడొచ్చు, సిబి వాడొచ్చు, సిసి వాడొచ్చు, ఏదైనా వాడొచ్చు మీరు పుష్ పుల్లో. ఎందుకు? అక్కడ ఎలాగో మీకు 2 ట్రాన్స్ఫార్మర్ వాడుతున్నారు మీరు, ఇన్పుట్ ట్రాన్స్ఫార్మర్, అవుట్పుట్ ట్రాన్స్ఫార్మర్ అని 2 ట్రాన్స్ఫార్మర్స్ మీరు వాడుతున్నారు కాబట్టి, సో మీరు సిబి అయినా, సిఈ అయినా, సిసి అయినా ఏదైనా ఇంపిడెన్స్ మ్యాచింగ్ మీకు ఈజీగా మ్యాచ్ అయిపోతుంది. ఓకే, ఈజీలీ యూ కెన్ మ్యాచ్, సో దట్ అక్కడ ఏ కాన్ఫిగరేషన్ వాడొచ్చు. బట్ ఇక్కడ కాంప్లిమెంటరీ సిమెట్రీలో ఆర్ దేర్ ఎనీ ట్రాన్స్ఫార్మర్స్ ఇన్ ది సర్క్యూట్? ఆర్ దేర్ ఎనీ ట్రాన్స్ఫార్మర్స్? No transformer. So if we use in the place of the CE amplifier వాడారు అనుకోండి, CE amplifier output impedance is moderate. CB amplifier వచ్చేసి output impedance is high. You cannot use these 2 amplifiers in the place of CC. CC output impedance is low, so you are forced to use CC amplifier in the complementary symmetry. Why? Because no transformer are used here. In the push pull వచ్చేసి 2 ట్రాన్స్ఫార్మర్ వాడుతున్నాం కాబట్టి యూ కెన్ యూజ్ సిఈ వాడవచ్చు, సిబి, సిసి ఏదైనా వాడుకోవచ్చు. బట్ ఇక్కడ మాత్రం కాంప్లిమెంటరీ సిమెట్రీలో ఓన్లీ సిసి మాత్రం వాడతాం. ఎందుకు? అవుట్పుట్ ఇంపెడెన్స్ లో ఉంటుంది కాబట్టి. ఓకే, దిస్ స్ట్రక్చర్. సో నౌ నెక్స్ట్ వన్ ఇస్, సో ఫర్ ఎగ్జాంపుల్ యు ఆర్ గివింగ్ సైనూసోయిడల్ సిగ్నల్ లైక్ దిస్. ఓకే, ఫర్ పాజిటివ్ పీక్ ఐఎమ్ గివింగ్, అండ్ హియర్ ఆల్సో పాజిటివ్ పీక్ ఐఎమ్ గివింగ్. రెండింటి సేమ్ వెళ్తుంది. ఇక్కడ ట్రాన్స్ఫార్మర్ లేదు కదా, సో పాజిటివ్ పీక్ ఇస్తే పాజిటివ్ పీక్. ఇది ఎన్పిఎన్ కాబట్టి సో పాజిటివ్ పీక్ కండక్ట్ అవుతుంది. దిస్ విల్ బి ఆన్, అండ్ దిస్ ఇస్ పిఎన్పి కదా. పిఎన్పి అంటే ఏంటి? పిఎన్పి. ఓకే, దిస్ ఈస్ ఎన్పిఎన్, పాజిటివ్ టు పాజిటివ్ కండక్ట్. దిస్ ఈస్ వాట్ నెగిటివ్ పాజిటివ్ ఇస్తున్నారు, సో Q2 ఈస్ ఆఫ్. సో అవుట్పుట్ ఏమొస్తుంది? ఇది బ్లాక్ అయిపోయి అవుట్పుట్ ఈ పీక్ అనేది వస్తుంది, ఈ పీక్ అనేది వచ్చేస్తుంది. సో అవుట్పుట్ విల్ బి లైక్ దిస్. ఓకే, సో పాజిటివ్ పీక్ అనేది ఇట్లా వచ్చేస్తుంది. అంటే ఫర్ ఎగ్జాంపుల్ ఐ విల్ టెల్ యూ సేమ్ ఎక్స్ప్లెనేషన్. ఇక్కడ ఒక Q1 ట్రాన్సిస్టర్, Q2 ట్రాన్సిస్టర్ ఉంది. ఓకే, ఇక్కడ లోడ్ రెసిస్టెన్స్ ఇలా ఉంది RL. ఇక్కడ ఇన్పుట్ ఇస్తున్నారు మీరు. ఓకే, VA ఫస్ట్ పాజిటివ్ పీక్ ఇస్తున్నారు. సో ఇక్కడ పాజిటివ్ వెళ్తుంది, ఇక్కడ పాజిటివ్ వెళ్తుంది. సో దిస్ ఈస్ పిఎన్పి ట్రాన్సిస్టర్, దిస్ ఈస్ ఎన్పిఎన్ ట్రాన్సిస్టర్. ఎన్పిఎన్ ట్రాన్సిస్టర్ కండక్ట్స్ ఫర్ ద పాజిటివ్ పీక్, పిఎన్పి ట్రాన్సిస్టర్ కండక్ట్స్ ఫర్ ద నెగిటివ్ పీక్. అంటే ఇది బ్లాక్ అయిపోతుంది ఇక్కడ. సో పాజిటివ్ పీక్ విల్ ప్రాసెస్ అండ్ అవుట్పుట్ విల్ బి ప్రాసెస్ లైక్ దిస్. Similarly, suppose you take again Q1, Q2, load resistor, నెగిటివ్ పీక్ ఇస్తున్నాను ఇక్కడ. పాజిటివ్ పీక్ అయిపోయింది కదా, నెగిటివ్ పీక్. సో ఇఫ్ అప్లై ద నెగిటివ్ పీక్ హియర్, దిస్ విల్ బి ఆఫ్. సో ఇక్కడ బ్లాక్. నెగిటివ్ పీక్, దిస్ విల్ బి ఆన్. వై? బికాస్ దిస్ ఇస్ ద పిఎన్పి ట్రాన్సిస్టర్. సో దిస్ విల్ బి ఆపోజిట్ లో వచ్చేసి మీకు ఇట్లా ప్రాసెస్ అవుతుంది. ఈ రెండే యాడ్ చేయండి, ఏమొస్తుంది? సిగ్నల్ ఇలా వస్తుంది కదా. సో పాజిటివ్ పీక్లో వచ్చేసి Q1 ఆన్, Q2 ఆఫ్. ఇక్కడ వచ్చేసి Q1 ఆఫ్, Q2 ఆన్. Am I right? So PNP transistor will be conduct for negative peak, NPN transistor will be conduct positive peak. Okay, any doubts in this operation? Any doubts? ఎవడో ఒక రెస్పాండ్ అవ్వండి బాబు.
No, sir.
ఓకే, సో ఓన్లీ 2 ట్రాన్సిస్టర్స్ వేర్ గివింగ్. పాజిటివ్ పీక్ ఇస్తే Q1 ఆన్ అవుతుంది, నెగిటివ్ పీక్ ఇస్తే Q2 ఆన్ అవుతుంది. బట్ 2 ప్యారలల్ ఉన్నాయి కాబట్టి ఏ ఒక్క ట్రాన్సిస్టర్ ఆన్ అయినా కానీ ఆ పీక్ అనేది అవుట్పుట్లోకి రిప్రజెంట్ అవుతుంది. ఓకే, సో దిస్ ఆపరేషన్ is quite different from your push pull, quite different, and the remaining everything is same as your push pull. No difference. Okay, only thing is that node point you have to write it as is the ఇక్కడ ఏముంది పుష్ పుల్ ఏం రాశారు ఇక్కడ. ఫర్ ఎగ్జాంపుల్ పుష్ పుల్లో ఇక్కడ చూడండి V1M I1M రాస్తాం. ఇక్కడ 1 ఇండికేట్స్ ఏంటి, ప్రైమరీ. ఇక్కడ ట్రాన్స్ఫార్మర్ ఉంది కాబట్టి 1 2 అనేది సెపరేట్ ఇండికేట్ చేసాం. అండ్ RL ప్లేస్లో RL డాష్ అని రాసాం, అంతేనా. RL డాష్లో RL ప్లేస్లో RL డాష్ అని. ఇప్పుడు కాంప్లిమెంటరీ సిమెట్రీలో V1M I జస్ట్ రైట్ ఇట్ యాజ్ VM IM/2 IM square into RL by 2. Okay, that is only the difference. Everything copy paste, no change at all in this. Only operation is different, everything is same. ఓకే, సో అక్కడ V1M I1M ఉన్నాయి, దాని ప్లేస్లో VM అని పెట్టాలి, RL డాష్ ప్లేస్లో RL పెట్టాలి, అంతే. వై బికాస్ అక్కడ మీకు ట్రాన్స్ఫార్మర్స్ ఉన్నాయి కాబట్టి అన్ని డిఫరెన్షియేట్, ప్రైమరీ ఏంటి, సెకండరీ ఏంటి, లోడ్ ఏంటి, ప్రైమరీ లోడ్, సెకండరీ లోడ్ అంత ఉంటుంది. ఇక్కడ వీఆర్ నాట్ యూజింగ్ ఎనీ ట్రాన్స్ఫార్మర్. సో V1IM becomes VMIM, RL dash becomes RL. Same derivation, everything copy paste. So only thing is complementary symmetry లో కూడా push pull same as it is copy paste. No change. దీనికి కూడా 78.5% వస్తుంది. Power dissipation derivation same, everything is same. Okay, the final thing. Oh, so now 4 are over. 4. Now tell me, సో వీటిల్లో ఈ 4 ఇట్లా ఎన్ని చదువుకుంటే మీకు బెటర్గా ప్రిపేర్ అవ్వగల. 4 వచ్చేస్తాయి మీకు. ఓన్లీ థింగ్ ఏంటంటే సిరీస్ ఫెడ్ ఒకటి ప్రిపేర్ అవ్వాలి, పుష్ పుల్ ఒకటి ప్రిపేర్ అవ్వాలి. సిరీస్ ఫెడ్ ప్రిపేర్ అయిన తర్వాత ట్రాన్స్ఫార్మ్ కపుల్డ్కి సిరీస్ ఫెడ్కి డిఫరెన్స్ ఏమొస్తుంది. సిరీస్ ఫెడ్ క్లాస్ ఏ పవర్ యాంప్లిఫైర్కి ట్రాన్స్ఫార్మర్
ఎఫిషియన్సీ.
అదే ఎక్కడ ఎఫిషియన్సీ ఎందుకు ఇంప్రూవ్ అయింది, ఎక్కడో ఒక చిన్న పాయింట్ దగ్గర చేంజ్ చేసి ఉంటాం కదా ఎక్కడో.
Vmax value.
Vmax వాల్యూ VCC అవుతుంది ఎక్కడ, సిరీస్ ఫెడ్లో. ట్రాన్స్ఫార్మర్ కపుల్డ్ వచ్చేసి
2VCC.
అవుతుంది. అది తప్పించి మిగతాదంతా సేమే కదా. ఎనీ డిఫరెన్స్ అదర్ దాన్ దట్ పాయింట్?
No sir.
సర్క్యూట్ ఒకటి డిఫరెంట్, అంటే సర్క్యూట్ అక్కడ సిరీస్ పెట్టి ట్రాన్స్ఫార్మర్ ఉంటుంది, ఆ ఒక్క పాయింట్ డిఫరెంట్. నెక్స్ట్ క్లాస్ బిలో పుష్ పుల్కి కాంప్లిమెంటరీ 2 ఉన్నాయి. పుష్ పుల్ వచ్చేసి ట్రాన్స్ఫార్మర్తో ఇన్పుట్ ట్రాన్స్ఫార్ అవుట్పుట్ ట్రాన్స్ఫార్మర్ పెడతాము, అదంతా డెరివేషన్ చేస్తాం V1M I1M RL డాష్ తీసుకొని. కాంప్లిమెంటరీ సిమెట్రీలో ఆ ట్రాన్స్ఫార్మర్ లేపేసి CC కాన్ఫిగరేషన్ వాడుతున్నాము. ఓకే, CC కాన్ఫిగరేషన్ వాడేసి what we call so same derivations. Operation కొంచెం డిఫరెన్స్ ఉంటుంది, బట్ డెరివేషన్స్ ఎవ్రీథింగ్ ఇస్ సేమ్. జస్ట్ కాపీ బ్లైండ్గా. మీకు ఈవెన్ మీకు ట్రాన్స్ఫార్మర్ కపుల్డ్కి సిరీస్ పెట్టుకు ఒక పాయింట్ డిఫరెంట్ ఉంది కదా, అలాంటి పాయింట్ కూడా డిఫరెంట్ లేదు ఇక్కడ, సేమ్ యాజ్ ఇట్ ఈస్ కాపీ పేస్ట్ చేయడమే. ఓకే, సో యూ హ్యావ్ టు ప్రిపేర్ సిరీస్ ఫెడ్ క్లాస్ ఏ పవర్ యాంప్లిఫైర్ ప్రిపేర్ అవ్వండి. పుష్ పుల్ క్లాస్ బి ఈ 2 ప్రిపేర్ అయిపోతే ఆ రెండోది వచ్చేస్తుంది, ట్రాన్స్ఫార్మర్ వచ్చేస్తుంది, కాంప్లిమెంటరీ వచ్చేస్తుంది. సో ఈ రెండిట్లో ఒక క్వశ్చన్ అయితే డెఫినెట్గా ఉంటుంది. ఇందులో కూడా మీ పెద్ద డెరివేషన్స్ ఏం లేదు, ఓన్లీ ఎఫిషియన్సీ క్యాలిక్యులేట్ చేయడం. నీటా ఈజ్ ఈక్వల్ టు పిఎస్సి బై పీడీసీ తీసుకోవాలి. పీడీసీ ఏంటి, పిఎస్సి ఏంటి క్యాలిక్యులేట్ చేసి సబ్స్టిట్యూట్ చేయాలి, అంతే. ఎనీ డిఫికల్టీ ఇన్ దిస్? Any difficulty point? Understood? Any doubts or otherwise any doubts if you have? It's clear?
Clear, sir.
So one more topic, and not topic, a small thing. 2 మార్క్స్ క్వశ్చన్స్ అడిగే ఛాన్స్ ఉంటుంది. ఇది క్రాస్ ఓవర్ డిస్టార్షన్ అంటాం. ఇది కూడా లేదు మన సిలబస్లో అయితే లేదు, బట్ లెట్ us discuss cross over distortion. Crossover distortion. Okay, so in this crossover distortion, input signal less than below. ఓకే, ఇది క్లాస్ బి పవర్ యాంప్లిఫైర్కి ఇస్తున్న ఇన్పుట్. క్లాస్ బి పవర్ యాంప్లిఫైర్ ఎన్ని ట్రాన్సిస్టర్లు? 2 ట్రాన్సిస్టర్లు వాడుతున్నాం. వాట్ ఈస్ ఎన్పిఎన్, అనదర్ ఇస్ పిఎన్పి ట్రాన్సిస్టర్. దిస్ ఈస్ ప్లస్ 0.7 volts, దిస్ ఇస్ మైనస్ 0.7 volts. ఓకే, ఇసి ఇక్కడ పాజిటివ్ పీక్కి ఇది కండక్ట్ అవుతుంది అంటున్నాం. దిస్ ఈజ్ ఆన్ అంటున్నాము, ఇది ఆఫ్ అంటున్నాం. ఓకే, నెగిటివ్ పీక్ ఇది ఆఫ్ అంటున్నాం, ఇది ఆన్ అంటున్నాం. ఓకే, బాగా. సో ఈ ట్రాన్సిస్టర్ ఆన్ అవ్వాలంటే ఎప్పుడు ఆన్ అవుతుంది? ఇఫ్ దిస్ పాజిటివ్ పీక్ ఇస్ మోర్ దాన్ 0.7, అంటే ఇక్కడ కటింగ్ వోల్టేజ్ ఉంటుంది కదా, ఇది విబిఈ ఉంటుంది కదా. విబిఈ, వాట్ ఈస్ ద వాల్యూ ఆఫ్ విబిఈ? 0.7. అంటే మీకు పీక్లో 0.7 కన్నా ఎక్కువ వస్తేనే మీకు ఈ ట్రాన్సిస్టర్ ఆన్ అవుతుంది. ఓకే, ఐడియల్ ట్రాన్సిస్టర్ అంటే 0 ఉంటుంది కటింగ్ వోల్టేజ్, బట్ ప్రాక్టికల్ ట్రాన్సిస్టర్ వచ్చేసి ఇది ఏముంటుంది మీకు? 0 ఉంటుంది. ఓకే, సో కటింగ్ వోల్టేజ్ 0.7 ఉంటుంది. సో పాజిటివ్ పీక్ అనేది మోర్ దాన్ 0.7 అయితేనే మీకు అవుట్పుట్ వస్తుంది. Am I right? Similarly, the PNP transistor negative peak కండక్ట్ అవుతుంది. ఓకే, నెగిటివ్ పీక్ ఎందుకు కండక్ట్ అవుతుంది? సో ఇక్కడ -0.7 ఉంటుంది ఒకటి, -0.7 కన్నా ఇంకా తక్కువ ఉంటే, ఐ మీన్ లెస్ దాన్ దట్ ఉంటేనే ఈ ట్రాన్సిస్టర్ ఆన్ అవుతుంది, అదర్వైజ్ ఇట్ వోంట్ ఆన్. ఇస్ ఇట్ రైట్? సో ఇక్కడ వచ్చేసి ఏమవుతుందంటే, సో పాజిటివ్ పీక్ అండ్ నెగిటివ్ పీక్ ఓకే, సో ఇక్కడ పాజిటివ్ పీక్ అనేది లెట్ us సే ఆన్ అవుతుంది. పాజిటివ్ పీక్ వచ్చేసింది, ఇక్కడ ఆన్ అవుతుంది. ఓకే, సో ఈ బిట్వీన్ దిస్ పాయింట్ అండ్ దిస్ పాయింట్, సో ఈ లైన్ ఏముంటుంది? దిస్ లైన్ ఈస్ లైస్ బిట్వీన్ ది ప్లస్ 0.7 టు -0.7. ఇఫ్ ద సిగ్నల్ ఈస్ లైస్ బిట్వీన్ +0.7 టు -0.7, neither of the transistor will be on, both the transistor will be off. If the input signal 0.7 ki and input is ఈ లైస్ బిట్ ఉంటే -0.7 నుంచి 0.7 సిగ్నల్లో మీకు ఇన్పుట్ ఉంటే అవుట్పుట్ విల్ బి 0. మీకు ఏ ట్రాన్సిస్టర్ ఆన్ అవుతుంది ఈ పీరియడ్లో? వై? బికాస్ పాజిటివ్ ఎన్పిఎన్ ట్రాన్సిస్టర్ విల్ బి ఆన్ అబౌవ్ 0.7, పిఎన్పి ట్రాన్సిస్టర్ విల్ బి ఆన్ బిలో -0.7. సో ఈ పీరియడ్లో ఉంది. నెక్స్ట్ ఇక్కడ వచ్చేసి మళ్ళీ సేమ్ వస్తుంది, మళ్ళీ ఈ గ్యాప్లో ఏముండదు. ఓకే, సో దిస్ డిస్టార్షన్ వి కాల్డ్ crossover distortion. Crossover distortion. So the NPN transistor will be on above +0.7 volts. PNP transistor will be on below -0.7 volts. So between input is lies between -0.7 and 0.7. Neither of the transistor will be on. Therefore, the output voltage will be 0 between the period between the -0.7 to +0.7. So that zero or that distortion we call it as crossover distortion. Okay, how to eliminate this crossover distortion? How to eliminate crossover distortion? Elimination of crossover distortion is, so మీకు ఎలాగో ట్రాన్సిస్టర్ ఉంటుంది కదా, ఓకే, కెపాసిటర్స్ C1 C2 ఇది RL. ఓకే, ఇదే కదా ట్రాన్సిస్టర్స్. సో ఇప్పుడు మీకు ఏంటి ప్రాబ్లం ఏంటి, మొత్తం టోటల్ ప్రాబ్లం ఆఫ్ -0.7 టు +0.7 అంటే టోటల్ 1.4 వోల్ట్స్ మీకు ప్రాబ్లం ఉంది. ఈ 1.4 వోల్ట్స్ కనుక మీరు ఎక్స్టర్నల్గా ఇవ్వగలిగితే, ఈ 1.4 వోల్ట్స్ మీరు ఎక్స్టర్నల్గా ఇవ్వగలిగితే అదర్ దాన్ దిస్ ఇన్పుట్ సిగ్నల్, దెన్ ద ట్రాన్సిస్టర్ విల్ బి ఆన్. Is that right? Right. So for that, what we are doing is, I am connecting one resistor, and here I am connecting two diodes in series. Okay. What is the cut-in voltage of this 0.7? This is 0.7. Total length also the total 1.4 volts. If you connect these diodes externally, what happens is the potential of the diodes will become 1.4. That 1.4 volts will use to on the transistor without depending on input signal. And previous circuit ఏం చేస్తున్నారు, ఆ ఇన్పుట్ ఇచ్చేస్తే అది ట్రాన్సిస్టర్ ఆన్ అండ్ ఆఫ్ కండిషన్ ఆల్సో డిపెండ్స్ ఆన్ ది ఇన్పుట్ సిగ్నల్. బట్ నౌ ఐఎమ్ గివింగ్ ఎక్స్టర్నల్ సప్లై, 2 డయోడ్స్ సిరీస్ లో కనెక్ట్ చేస్తున్నాను ఇన్ బిట్వీన్ ద బేసెస్ ఆఫ్ 2 ట్రాన్సిస్టర్స్. బేసిస్ ఆఫ్ 2 ట్రాన్సిస్టర్ కనెక్ట్ చేయడం వల్ల ఏమవుతుందంటే ఇట్ ఆఫర్స్ 1.4 వోల్ట్స్. సో ఈ 1.4 వోల్ట్స్ ఏం చేస్తాయి, మీకు ఒక +0.7 వచ్చేసి ఎన్పిఎన్ ట్రాన్సిస్టర్ ఆన్ అవుతుంది, ఇంకొక -0.7 వచ్చేసి పిఎన్పి ట్రాన్సిస్టర్ ఆల్రెడీ ఆన్ అయి కూర్చుంటాయి. సో దెన్ when you apply the input signal, automatically that input signal will process. Okay, so this is the elimination. Just it may ask for the 2 marks question. Okay, so this is today's class. Actually, ఏ టైం వరకు 12 క్లాస్ టైమింగ్ ఎప్పటికి
9:10 to 10:40, 11 to 12:40, sir.
12:40. Okay.
12:40.
Okay. So this is power amplifiers. You please prepare only that class A power amplifier and the push pull, and from that you find out what is the difference between the series fed and this one. Okay. And the later, of course, you can write the comparison of push pull and complementary. You write it comparison of push pull and complementary. What are the points? Push pull transformers are required. Complementary, no transformer required.
Common collector.
Sorry.
We will use common collector instead of transformer.
Yeah. In the push pull, even you can use CE, CB, CC configurations, but push complementary వచ్చేసి only CC configuration వాడాలి. Next difference. Push pull, both the transistors are same type. Complementary, both the transistors are opposite type. Next. Next what?
In push pull, there will be no crossover.
Of course, there is also crossover distortion. This is class B అంటే మొత్తం రెండిటి కలిపి. Okay. Next push pull కి వచ్చేసి ఎన్ని సప్లైస్ వాడారు చూడండి. పుష్ పుల్ కి ఎన్ని సప్లైస్ వాడారు? ఓన్లీ 1, రైట్? ప్లస్ 1. అదే కాంప్లిమెంటరీ కి వాడారు 2. అది డిఫరెన్స్. పుష్ పుల్ కి సింగిల్ సప్లై సరిపోతుంది, బట్ కాంప్లిమెంటరీకి వచ్చేసి 2 సప్లైస్ కావాలి. నెక్స్ట్ పుష్ పుల్ వచ్చేసి కాస్ట్లీ, బికాస్ 2 ట్రాన్స్ఫార్మర్స్ ఆర్ యూజింగ్ నో, కాస్ట్లీ. కాంప్లిమెంటరీ వచ్చేసి చీప్. పుష్ ట్రాన్స్ఫార్మర్స్ ఉన్నాయి కాబట్టి ఫ్రీక్వెన్సీ రెస్పాన్స్ ఇస్ పూర్, కాంప్లిమెంటరీకి వచ్చేసి ఫ్రీక్వెన్సీ రెస్పాన్స్ ఇస్ గుడ్. So these are the comparison of push pull and complementary. Clear? Okay, I will give you the handout of only the derivation part of it. So I will type it and I will give you, so that as I told in the previous class, so short notes. So please prepare that sheet completely. Okay, there are some problems also there in the back side of it, and I will give you, and keep it with you, and don't share it with anybody. And actually, so it's very confidential. I'm not supposed to share. Actually, it's okay. I will give you the power amplifiers. Keep it confidential. Don't share with anybody. Okay.
Okay, sir. Okay, sir.
Uh, So this is, and afternoon. So sir will take, Murli Prasad sir will take for SS. CR, and one more announcement from my side. And from Thursday, Friday, Saturday, there will be class test on Unit 1. It is a batch ka a batch రోజు ఉంటుంది. Thursday batch, Thursday, Friday, and Saturday batches. I already informed to see your CRs, both CRs, Varun and Mahalashmi. I think they are already informed you. And from my end,
Yes.
I'm telling you. So Thursday, Friday, Saturday batch ki first 1 hour or 1.5 hour exam ఉంటుంది ఆ రోజు batches ki. Okay, that is one. CR, వరుణ్,
సార్ సార్
మురళీప్రసాద్ సార్ ఆఫ్లైన్ క్లాసెస్ తీసుకుంటా అన్నారా ఇదివరకు ఎప్పుడైనా?
1 day తీసుకుంటా అన్నారు సార్.
అంటే సార్ ఇది వచ్చేసి ఈరోజు పిలవలేదా, నేను ఆఫ్లైన్ క్లాస్ తీసుకుంటానే అన్నాడు, నాకు ఇన్ఫర్మేషన్ లేదు. మీతో ఏమైనా చెప్పారా ఇది వరకు అట్లా?
అంటే మమ్మల్ని అడిగారు సార్ ఆఫ్లైన్
1 day తీసుకుంటా అన్నారు కానీ ఎప్పుడో చెప్పలేదు సార్.
ఆఫ్లైన్ ట్రై చేస్తా అన్నాడు సార్, కానీ ఎప్పుడో చెప్పలేదు సార్.
ఓకే, సార్ పిలిపిమంటున్నారు, మరి రేపు రావాల్సి వస్తుందేమో అందరూ. మరి నేను చెప్తాను, నేను మళ్ళీ
Okay,
మెసేజ్
sir.
చేస్తాను.
ఓకే.
నేను మళ్ళీ ఒకసారి హెచ్ఓడి సార్ని అడిగేసి కనుక్కుంటాను. ఓకే అంటే నేను ఇన్ఫార్మ్ చేస్తాను. ఓకే, సో ఎనీ క్వైరీస్ యూ కెన్ డిస్కస్. Any queries?
No sir.
సార్
No, sir.